bum, bum, bum. How's it going today? I'm tired. I am tired. I got a little drinky last night, which is not something I should be doing. But, well, bad habits and all that. I'm drinking my own body weight in water today. I was up late. Rob Oz raided Sark, and Sark was doing some pretty hilarious stuff. Ended up watching that for way too long. Look at this. This new solder. Look at this. I got it's 1 pound of solder. Oh, look at how cold my fingertips are. Circulation. Diabetes. Look how small this solder is. It's so small. But I got like a freaking pound of this stuff. I don't know what I'm gonna do with it. I don't think it'll work in the solder spool, because I think that solder spool over there will kill it. By the way, we're getting dangerously close. I have the new reel of this exact stuff coming today. I probably should remake this base. I like how it's all oxidized and stuff, but like, man, this is amateur hour. This thing, maybe I could put it in the mill and just like clean it up. Make it look a little bit more fancy. And put a bother sticker on it. Hold on, I'm gonna cough. All right, I'm back. Yeah, I should clean this up in the mill. This is like a pre-milling machine project from a long, long time ago. Like, I literally just toss this in on the mill right now and just clean up all the edges. I'll have to do that at some point. But yeah, dangerously close to the end of the solder reel. End of an era. That was my streamer solder. Starting a little late. I practically, for all intents and purposes, I woke up under the bed, so I didn't actually wake up under the bed, but that's what it feels like. I guess I'm not really gonna need this today. We're not gonna do like tiny soldering stuff, right? Yeah, number one. How's it going, Schmud? Number one. Keeping this stuff from like looping on itself is going to be tough. But when we do need smaller solder, I'm definitely going to have a large supply of it. And this is like, I probably should have looked for a reel that wasn't 1 pound, huh? An entire pound of solder. Well, here it is. Looks like it's coming unraveled over here a little bit. It's not good. That's not good because it goes to like the other layers of the solder. Ugh. Ugh. All right, well. 2 pounds? No, 1 pound. 1 pound. Oh, I see. Yeah, because it came out. No, wait, no. It didn't. It's all right. All right, I'm gonna put this aside. Just so I don't end up playing with it until it becomes completely unraveled and stupid. Let's boot up the system here while we're hanging out ahead of stream. I'll loosen this ball mount a little bit. I over-tighten the ball mount. I need to put like a limiter on how tight it gets because I need the ball mount to be able to slide a little bit, so I can actually like pose the camera. It's a little bit too professional of a thing, where if you adjust that tightness, it'll hold it in place forever and ever. It's not like welding wire. It's not gonna, welding wire you gotta be really careful with because it'll completely unravel if you break the, if you break it free. It's not like that. Fortunately for us, solder does not act that way. But I mean, it's the same with like 3D printer filaments and stuff, right? You don't want it to accidentally catch. Yeah, don't tweak your ball mounts too much. Oh man, we gotta get going streaming because I feel like shit today, and I shouldn't, but I do. So we'll get going, and then I'll feel a little better. I haven't touched it. If it changed, if the FOV of this camera changed, there's 3 settings on it, and I don't really access them on a day-to-day. The 3 settings, the only way to get into them is with Logitech settings program. So, but there are 3. There's 90, 75, and then I think like something in between. I like to have as little as possible because there's a fisheye effect. You can see like these lines should be straight, and they're mostly straight, but when you look at them like the edge of the table seems to like bow. This is just the FTL soundtrack that I'm playing today. I almost don't need to give credit to this. It's just off YouTube. I don't think anything will get copyright struck from that. I don't think. It is game music, so. I don't think it does 120 degrees, does it? Is that one of the settings? 120 degrees? That's insane. That's a really wide lens. So everything looks like shit. I mean, I can power this on for now. Yeah, let's just power it up. Boop. I do want to shuffle the pins on this thing so that the serial signal coming back takes on a logical gear number. I don't know if it should be transmitting it this way. It feels like maybe it should be transmitting a number back. I guess it doesn't really matter that much. And it's easier for the software to kind of just like throw stuff around instead of actually translating it to like a number. Instead, I can just take that packet and shift it in to the to whatever the output is. Although actually, it's going to have to assemble a serial packet and send that to the controller. How's that going to work? Man, the serial decoding, I'm not looking forward to because I don't know anything about it. Oh man, sorry. Whoa. 6 burps in a row. Didn't help myself out with what I had for lunch. I had like a bread salad. I don't know what the fuck that thing was, but it was just like bread and balsamic vinegar and like olives and a little bit of cheese. Which all are terrible, terrible things for heartburn. So is drinking the night before. So I'm gonna be a struggle bus today. We're gonna have some fun. I'm gonna be pounding water like it's going out of style. That's what I'm gonna be doing. Look at that. Beautiful. 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 All with an appropriate checksum accompanying it. Oh, that didn't actually shift. What was that? That was weird. Not that you'll be choosing gears like this. You know, typical use will be 1 to 2 to 3 to 4, and maybe a little occasional reverse, but reverse. I'll change around where those signals are. We'll solve the puzzle. The matching shift position puzzle. Where's that code? Right here. There's that code. Look at that code. Beautiful. Yeah, so what pin is what? Basically what I did last night was I finished building the circuit that we were building. That was not hard to do without chat here. That was not hard to do without you guys. Basically just ran a bunch of wires to all the stuff, plugged it all in, tested it. Turns out I didn't solder VCC, so whatever. None of the power was getting delivered to this thing, but yeah, we've got the little LIN bus circuit down there, and then the Arduino is sitting up beside it. Now the LIN bus input from right here No, no, I wasn't drinking while doing this. But yeah, basically just solder all the wires to the switches, route them. It was actually fairly difficult to get that to reach. And then I did a little strain relief zip tie at the top of the little things. See that zip tie right there? That's just strain relief because those wires are just kind of dangling. And that's it. Bob's your uncle, right? Once I figured out that VCC problem, it all started working. Because I'm good at what I do. Because I know what I'm doing. Boop. Yeah, so which one's which here? First gear. Well, it's like first gear is actually in the right position. Because that's our leading 0 for the serial packet. And that's our first one. We're looking at the 12 volts right now because I had to break down, I had to move the LIN bus modem over here. So, after the modem, the signal's much cleaner. Well, second gear is the very last position. So we actually need to swap reverse and 2. 3 and 9. What? Crazy Uncle Bob? I think I've heard of that. Good space music. Yeah, this is FTL. If you have not played this game, look into it because it is a great game. It is a wonderful game. Rumored that it was the game was created to fit the music. Although, you know, take that with a grain of salt, but apparently the creator of the game simply wanted music to go with his or wanted a game to go with his cool soundtrack. Looks like this is the second position, so 2 and 3 get reversed. Wait, yeah, 2 and 3. Yeah, it is a wonderful game. There's a mod that like vastly expands it. It's kind of unfortunate that we haven't had a game like it since then. I know the FTL people have made other games since then, and they look okay, but they're not FTL. FTL's awesome. All right, so that's third gear. Fourth gear is going to be harder to find. Wait, so first gear, second gear should be third gear. Oh boy, this is tough to do. Fourth gear is second to last gear. So 5 is the second to last. No, that's 4. 4 is the second to last. So pin 5 goes to pin 7. So it's 5 and then 8. And now fifth gear. That looks like the third position. That looks like close to the fourth position. They don't look like they're next to each other. Looks like there's one in between them. I don't know. Let's, oh, here we go. That's the one I'm looking for. So, seventh gear. Well, seventh gear changed, so. Cortex Command. I never played that. Let's see if we can throw our code into here. Let's see, like, I'm not even doing a stream start soon because I'm just working on this thing naturally. I just want to get it done, you know? All right, goes on like that. And then we can hit upload over here. Com9 is recognized. Okay, everything else is set. Yeah, upload. What's going on here? Does it need to be disconnected in order to flash? It doesn't say. Oh, there it is. I don't know why that scrolled up. All right. So, first gear. Good. Second gear. Is that right next to it? Pretty much. Third gear. Okay, third gear is way out of whack. Fourth gear. Seems like third and fourth need a swapperoo. Third gear is the very last gear. Third gear should be reverse. Third gear should be 3. I guess I'm still plugged into it, so I might as well upload it. Weird take on lemmings. Oh, huh. I should do a Lemmings stream. I never played Lemmings. We didn't have a PC as a kid. We had Macs. First gear. Huh? Huh? What the deuce? What a, huh? 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 Well, first, third, I think second and third. Why is third all the way over there? Okay. I wonder how I'm arranging the packet when I put it together. Hold on. Hold on a minute. No, it's just logical. Everything I just shove it all in. Excuse me. Sorry, I don't mean to cough on stream. Okay. I'm just shoving them all in there. So what is the damn order? I've played Lemmings. I've played it. I just never had it. You know, I've played like 2 levels or 3. I haven't done a lot. But yeah, I have not played Lemmings much. We didn't have. I played Macintosh games, which were few and far between. Reverse bits. I don't think so. Neutral doesn't need to have a switch on it. It's all in how you program the game to see the gears, from what I understand. And if we do need a neutral button, we can do that on the receiver side. We can do that on the other side. Played Lemmings so much my floppy disk had a hole in it after it's been inserted too much into the Amiga. Don't copy that floppy. All right? Just don't do it. Don't copy that floppy. You'll end the internet if you do. I watched a video on this. Oh yeah, that's right. The measure cursor is on the wrong thing. Oh wait. Oh, now it's on the right thing. Oh, that's more useful. I didn't think I had that feature. All right, so we're looking at the size of 1 bit. So we'll do first gear, and we'll measure first gear. I just want to use that as a marker. So now we can, nope, that was the wrong one. I want to move you both at the same time. There we go, A and B move. All right, so we're looking for that. And that's so close to it. That's it. So right now, 1, 2, 3, 4, 5th gear is our second gear. Snurfity sniffing, yes. 1, 2, 3, 4, 5 is number 2. Okay, so one after that should be 3rd gear. But it is 3rd gear. Okay, so 3rd gear is good. 3rd gear is good. 4th gear. Are you holding up on your streamathon? I was up too late last night. I drank a little too much, so I'm feeling the years. I'm feeling like shit today. It's all my fault. So I'm just hydrating today. 4th gear. That's 4th gear. 4th gear is good. So 1 through 4 should be good right now. Let's try 5th. 5th gear is in the wrong place. We already solved that. Whatever was in 2nd gear is now 5th gear, which should be the last gear. Should be reverse, and reverse is almost... I think reverse and 5th gear need to be reversed. So 9 and then 4. Let's upload that and see if we get it right. In the same boat. Yeah. I shouldn't have done it. Shouldn't have done it. Problem is all that stuff affects willpower, and so once you put a hole in the dike, you get a flood. All right. 1st gear, 2nd gear. Damn it! 2nd gear is so wrong. Why? Why? What have you done? Why? 2nd gear. How did I so resolutely fuck that up? 1st, 2nd, or 3rd? I'm not sure. Hold on. That one should be reverse. 1, 2, 3, 4, 5 should be R. What is happening? How come these keep moving? I should probably take them like one at a time and figure it out instead of swapping numbers like I am, because whenever I move one, the other one moves, and so it's just kind of like a weird. So let's take them one at a time. Let's do them one at a time and figure out which one is where, because this is getting dumb. I'll just I don't know, put a comment with the previous number on it. Well, I mean, we know it's 2 through 9. We don't need to do that. Oop, I'm beeping. Hold on. Why am I beeping? Because my glucose level barely snuck above. I'm out of one of my medications, one of the ones that blocks sugar and salt. So I'm gonna have fun times injecting a lot of insulin over the next couple days until the prescription's ready again, which is weird because it's something that I take daily, but sometimes I don't take it, and I somehow ran out. I don't know how. I don't know what happened there. I need to look around. I think maybe I have a bottle of it that I don't know about. Usually I have like way too much because they give you like 180 days at a time, but I don't know. Okay, yeah, I'll just get rid of the music. We'll just pretend that we've been streaming this whole time. That's what I'm doing anyway. It's what I'm working on anyway, you know? I'm gonna have to use the bathroom in like 2 minutes, but that's just because I'm chugging water like I'm a fish. But yeah, I don't know. Instead of sitting here mindlessly, we're actually trying to figure out where these ones and zeros are supposed to go. And instead of transmitting like a number, which we could just do a binary number on this, and I could easily make that the thing. But it's not like we're gonna save the byte, so we'll just do one at a time. Means those kidneys are working well. Yeah, they're doing their job. I just wonder what's worse, feeling twice my age or my actual age. Twice is depressing, actual is depressing. It's also inescapable. I don't know, man. I just constantly am reminded of how fucking old I am compared to the rest of the internet. Like, oh, this streamer's pretty cool. And he's like, yeah, I can't wait to turn 22. And you're like, what? Son of a bitch. I'm like 1,000 years old. I was born in prehistory. You look like you're 20s. Well, that's nice. It's nice of you to say. People have said that. Mainly, it's probably because I've spent most of my time in a basement, locked away from society, shunned as a diabetic. They laugh at me. They see my pump and they go, "Is that a pager?" And I go, "Stop making fun of me." And they go, "Get back in the basement, diabetic." I'm like, Anyway, so yeah, I've been working on this thing and I haven't been able to stop myself. Mainly. For those of you that don't know, we have a very large simulator setup that is designed to clip to the side of a desk, and it involves actual real car pedals, which is a banned word on Twitch for some reason. I can't talk about a foot pedal without being arrested by the Twitch FBI. But we have actual car pedals from an E something or other BMW. Basically, just bought them on eBay. The gas pedal is actually the best one. By the way, if you guys are looking to like buy pedals, like a pedal box, like don't do yourself a favor and like see if you can actually use car pedals, because they're a lot cheaper than sim setup pedals. And if you want to make a special system out of them, they're going to take about as much effort anyway. I mean, there were some tricks, there were some weird tricks that I did with these pedals in order to get them to work properly, like, you know, 80-20 rail, replacing the cylinder and figuring out what the spring size needs to be, and then, you know, weirdly mounting the load cell on the brake pedal. There's some tricks, but if you're a little handy around hardware, you could probably do a good job to buy real car pedals. It's kind of awesome. I haven't been able to actually game with these yet, but we're working on the entire system. So those are the pedals. We more or less got them to a point where we could consider them somewhat pseudo-finished until we can get back around to them. The steering wheel speaks LIN bus, so everything else naturally has to speak LIN bus, and that's what we've been working on up here. You know, we've got the whole protocol. I made that when we worked on the pedals previously, but now we've made a new accessory for some new parts that I have running, because right here is the Steptronic shifter from an E46 M3. I happen to know that generation because it's the one that all my friends and I have owned. I actually, well, I never had an M3. I can't afford it, but I do have an E39, and I actually put my M steering wheel on it, and that like significantly updated the look of the car and the feel of the car. It made it feel like an E46. Anyway, so that generation all my friends have, and the meta for a little while was you swap out the Steptronic transmission with the manual, and that's like the cheap way to get an M3, which I probably should have done. Anyway, that thing was not that great. The operation of the shifter itself is great. Feels like a real car shifter. It's a complete package because this thing is just digitally communicating with the car computer in order to do all the gear shifting and stuff, right? It just has little normally open and normally closed switches on there that you put power to. That's pretty brilliant. It actually works very well. However, under our serial scheme, this was causing multiple shifts to happen. So I'd never remember what direction shift up and shift down is, and then I'd have to remind myself, and then I'd go to shift, and every now and then it would double shift, which in my summer car means that your 10 hours of car assembly, boop, instantly undone. Car explodes, and then you crash into a tree and die. So the solution is to look up something crazy, and I started to look at actual car shifters, but none of them, they're not like a closed package. That's, you know, the Steptronic thing is all electrical, but the shifter in an actual car is physically moving synchros and stuff. So you either have two cables or you have a lever, like two levers and a ball joint in the floor of the car. So unfortunately, I couldn't find a real car shifter. There were some options for things that I could get, but they were like $300 for like a couple of aluminum plates. So I'm not doing that. So I looked around and I found on Thingiverse the Open H shifter project. Pretty cool little project. We added some extra stuff to it though. I added a mount for taller, basically RC car struts are holding this thing in the center position, which gives it a little bit of a squish feel to it. It has a little bit of like, it kind of feels like you're doing work when you move it back and forth. It is a little loose. I could use larger springs than that. The base I redesigned a little bit because the original author of the shifter redesigned it to have ball bearings, which is a great idea. It gives it a nice feel. It's a nice loose feel, and then you can control everything else with hardware. But in doing so, they didn't do it right. They didn't do it right at all. They added bearings to all of the mounts of an aluminum shaft, and so it would be a freewheeling shaft. That's like it's ridiculous. Why'd you do that? So instead, I got rid of the outer bearings, and now that shaft is locked in place, but there are bearings on it that allow it to rock forward and back, or rock back and forth, or whatever. So anyway, those are the two mods, and then I also took the 110 millimeter tube, and I printed it, and we actually added a pattern to it in Fusion by using etching. Etching apparently wraps the design around something, as opposed to doing a solid or like a flat sketch. I tried all kinds of different stuff. The only good way to do it is by etching. It's so weird. Anyway, that was it. That's how we did the shifter. And so I swapped in as many parts as I could to make this thing work, and bought a really cheap shift knob from eBay that has the wrong shift pattern on it. I don't really care all that much, as long as you can see the gates of the thing. And then, yesterday, I put together a circuit board. So where we left off, this thing was basically ready to be finished. All I had to do was string the wire wrap wires from one end to the other in order to get all of the different pins of the switches set up. So the Arduino Pro Mini is currently monitoring those pins in what's called input pull-up mode. So that means that internal to the microcontroller, there is a resistor that is activated by a transistor, right? And it's a pull-up resistor. So it pulls it up to VCC, and when it sees it go low, aka when the switch is flipped between ground and the switch, then it will trigger as being hit, right? So all we do is grab that, we just look at the state of the pins, and then we throw it into a packet. Now I could get fancy with that. I could actually load the pin register and just put the pin register directly onto the packet line. I didn't do that. I did bit rights, which are silly, but it's whatever. It's whatever. It works, and that's all that matters. This Arduino is not really doing anything all that challenging. Probably could be a different Arduino, but whatever. It doesn't matter. I need to use up these Pro Minis somewhere. Camera focus. Camera focus. Yes. Okay, so that's that. I mean, I pretty much plugged it in, and it didn't work. And I was like, oh no, what's wrong? And so I took a look at the circuit, started poking around with the multimeter. It turns out I just didn't wire the VCC. I didn't wire the LIN bus power to the rest of the circuit. So once I connected that, everything worked. So brilliant. Anyway, so that's that. That's the shifter, and it works. I need to arrange the ones and the zeros to be in order, and then we can assemble all of our parts together, and we can just see what it's like. I want to try to clip the steering wheel to the side of the desk here, so we have access to all the buttons that it hits, and then put the shifter on the wheel. From there, we need to hook this thing up and figure out what the protocol is on this thing. Because what we're going to do is we're going to try to spoof. We're going to try to spoof these boards. I mean, there's one receiver board, but there can be multiple wheels that'll allow you to have 128 buttons. This has like 20 buttons on it. I think less than that actually, but you need to buy multiple of the $75 transmitters in order to communicate with the one receiver, in order to give you access, digital access to all the buttons, because they want you to put this into the module with a battery. So I could have like a battery operated shifter and a battery operated wheel. I don't want that. I don't want all that wireless communication going on. I want it to be over the LIN bus, because the LIN bus can handle it. And I want the direct communication in here. So we'll work on that. That's pretty much where the project is headed. And I also, once we get the pedal box connected to the wheel, I do need to like tune it a little bit, because this is the only thing that's really going to be useful in our old stuff anymore. Once we get the digital communication, is going to be those potentiometers, the digital potentiometers that I have in there, because we have a port expander currently. But I'm not married, no. All right, back over to here. So I'm trying to sort out what number pin goes to what thing. So I just need to do like the number matching game with this, which for some reason has been completely eluding me over the past couple minutes. I don't know why. I think it's because I keep swapping numbers and then they end up in a weird spot. So I'm just gonna go down the list and figure out which one is where. So first gear is where it should be. Basically what we're doing with the LIN bus, if you've never heard of the LIN bus, this is a system by which you can have a local, hold on. Jesus, that thing almost fell on the keyboard. All right, you go back up there, you hang out. Jeez. Every now and then I like brush my hand and it almost crashes stuff to the desk. All right. So what's going on here with the LIN bus? What is this? What is this? What is this? Well, right now I have the scope looking at the whole signal, and it's zoomed in on a portion of it, and we have a little diagnostic blip that we are triggering the scope off of, and that stabilizes the signal so that I can take a look at it and keep it still on the scope, right? Still on the axis. So what's happening is the LIN bus is requesting that everybody start listening up. It basically puts the line, the 12-volt line that goes to everybody low for a period of time, and for that period of time, everybody's counting cycles. They're going 1, 2, 3, 4, 5, 6, blah, 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 blah. And when they get to that number, they go, all right, I'm paying attention. So from there, the LIN bus, part of the protocol, because it's a one-wire signal, you never know how out of phase your clocks are, right? Everything can be a little bit funky when you have two remote devices. Same thing goes for RF. You see this in a lot of RF protocols because the radio wave is just one line of communication, right? So you have a little sync bit or byte, sorry, sync bit or byte, bit. You have a sync bit here. It's basically just 5-5. 5-5 is 1010, or yeah, it's 1010. You have your start bit, which is a 0, and then you have 1010, 1010. And so in that pulse time, all of your remote devices can sync up their timings to make sure that they are in phase with the bits that are with the data that's about to come in, right? Because everybody needs to make sure that all their timings are right. And we actually ran into that breaking by loading our code into a slightly more capable microcontroller. All of a sudden, everything was chaos, and the reason behind that was it wasn't timing this properly. And so it would register ones and zeros that looked like very slow ones and zeros, and it was getting a timing value for that, and then that would just set it off. It would just be bad from then on. So what we did is we put a little piece of code into the program, into the microcontroller that told it if your address is not called, don't save the timing data that you got from that 1 and 0 train. So it only saves the timing data when it recognizes the address. So this address right here, that little bit of data that follows the sync pulse, that is determining which one of the controllers on the bus is going to respond. If the address is correct, that controller waits just a little bit. It does all its work in the space right here. It does all the work that it needs to do. So it figures out what's going on, builds a packet, and then it starts replying given the same timing. And basically we have 2 bytes here. One is the state of the switches, and the other one is a checksum. We're not implementing the checksum, by the way. We're not doing anything with it back at the receiver. We haven't had to. We don't really have spurious signals on this. In a car, you have all kinds of different environments, like noise-wise. You know, somebody could shove their cell phone into your steering column, and you know, you don't want that to cause horrible noise or to change the radio channel or something weird like that. So you put a checksum at the end of it just to make sure that the data you're getting back is sane. In our case, we haven't really had any issue there. You explain an address and electrical signals. I understand computer science. How's that address created electrically? It's ones and zeros. So what we're doing is we're syncing up with a number, 5-5. That 5-5 gives us a certain amount of time where we can actually read when the pulse is where we read the location of the pulse, right? So now we're reading at all the right 1 and 0 locations. So then we jump into this and we're reading a 111 or like 11001 or something like that, right? So we get that number back, and if that number, the number that we programmed into both our device and the receiver and the transmitter, if we get that 0x1f here, we respond, but that number also contains a checksum. So it's actually a 6-bit address, and then it's got a little checksum at the back of it, which is it's like a what was that word that we used for it? Parity bit. What tells us the packet is terminated? Leading 0 and a following 1. That's when we know the byte has come through. And I just throw those out. I'm not doing anything with those. Technically, those are there, but all of this signaling, except for the initial listen pulse, everything has a leading 0 and a trailing 1. So that trailing 1 right there, I mean, that's supposed to be in there due to the timing standard. But like leading, this would be the trailing 1. It's a little big, but that is the trailing 1. So when I shift into like whatever, where's that one gear? When I shift into this gear, you can see that that pulse just expands because that's the 1 with the trailing 1 right behind it. So over here we have the shifter. I want to get these pulses to line up with the proper gears. So first gear, shift 1. That one looks like it's in the right spot because we have that leading 0. We have a leading 0. I wish I could get the scope like in focus and the shifter on the shot at the same time. Seems like I can't though. I bet the first place MSC players are all calculating parity. Yeah, well, we can shove it up there. Anyway, all right, second gear. Clearly not second gear. Where the hell is that one? What position on this is that? So like I am not a microcontroller. I am just sort of lazily figuring out what the positions of the 1s and the 0s are on this. It's hard to figure out where we are. That's why I set up this cursor in order to go bit by bit. So if I go to first, that's there. Let's look for second. So if I go on the edge of that, on the following edge of that, I'm looking for this one to be gear 2. It is clearly not that one. That one's wrong. That looks like it's the right thing. Is there anything that looks more correct? Not really. That one looks more correct. All right, so reverse, the number for reverse is actually the number for second gear. Really? I'm going to go down the list. I'm just going to like get rid of the numbers as I go. Oh, wait, but I think I need the old numbers just to figure out where we were. So let's do this. Let's just comment out all these numbers. And I'll just make this one 9. And then we'll look for third gear. Third gear, this one. Okay, that looks like it's kind of correct. I mean, yeah, that's kind of correct. All right, let's move the cursors after that because we're looking for 4. The third gear is correct. 3 is 3, which is just shocking that I got that right. When I wired up these basically what happens in this shifter is we're pushing buttons. We're just pushing buttons. So it's just 8 buttons that we press. Excuse me. When I wired them up, I have 2 5-pin connectors. So each bank of 4 buttons gets 1 ground and then 4 wires coming out of it. It's as simple as it could get. The only other way that we could complicate it more would be to somehow make it count in binary, which I don't know if I could really do, but that would be fun. But anyway, yeah, we're just like brute forcing it. It's just because basically all I did was sit here and wire it up, and I didn't care about what pin was connected to what. I just made it look pretty, and it doesn't really matter because I can go in and do this. You are descending a signal. Your microcontroller takes in the signal, parses it based on your program. Yes. So timing is important when you only have 1 wire running around. Like you don't have a clock signal to go off of. So you have to have this special protocol. And what we did is the steering wheel speaks LIN bus natively. So we had to figure out the protocol and program the bus master and then brute force the addresses so that we got the steering wheel's address and we found that it replied to us. So there's a lot of data in the steering wheel's reply, but the 1s and the 0s for all the buttons on the steering wheel, on the Mercedes steering wheel, are there. So we just get those. So basically the microcontroller, and by the way, when we looked it up, we didn't find a lot of stuff that really did LIN bus. Now there's like a whole GitHub like repository for multiple different projects that use LIN bus. And we could have just taken it. Yeah, sniffing. We're gonna be sniffing cereal in a little bit. Right now, I'm doing this. We're rearranging the pins on the shifter. But yeah, so we programmed the entirety of the protocol, but we made it match the actual LIN bus standards. So we were given timings and stuff like that we have to match in order to facilitate communication between devices. So as such, we couldn't just use the Arduino serial stuff, because we couldn't put this many low bits in because it would inject a 1 at the end of the byte. because it does the leading 0 and the following 1. So we brute forced this blatantly. It's all one thread of the microcontroller going through, going low for a certain amount of time, getting stuck, waiting, and then doing the 1s and the 0. All that stuff is manual with microsecond timings. It was a pain in the ass. Sniffing cereal, yes. Third gear is where third gear should be. What is fourth gear? What are fourth gear? Fourth gear is where fourth gear should be. So that one is the same. Some of these I got right. All right. Who's next? Uh-oh, this thing's gonna beep at me. I think it just buzzed me. Nope, something else in the house did a little beep. Huh. A few months later, we learned interrupt timing. Yeah, I didn't do interrupts for this. And actually, the important thing about what we learned with the ATtiny85 was how to directly control the timing registers. And so that you can really pare down your microcontroller with. You are one thread, and you are running on the base code of the microcontroller, and you can very tightly control your timings and stuff. You get much more consistent results doing that too. But I didn't implement that in this. We got away with the bare minimum of communication protocol. A friend of mine did something very similar to what you did. He had an Arduino sniffing the CAN bus, getting his steering wheel position. He then draws the steering wheel in the console screen. Oh, that's cool. That's cool. Yeah, I mean, the Granite Devices controller does most of that stuff for us, like the steering wheel position and stuff. We had to fool the Granite Devices controller into thinking that we had physical buttons connected to it, because that's apparently how the Scandinavians do things, and they decided that I wouldn't get an API. Their webpage for the API went dead, and there's no Wayback Machine on it, and I am sad. It would be very nice if we had, you know, like an API where we could digitally communicate with this fucker. I would very much rather, instead of having potentiometers fool this thing into thinking that there is a potentiometer connected, I'd rather just tell it what the bytes are for the analog value that I'm sending into the damn thing. But unfortunately, my use case is fairly unique and not really all that common. And it also forces people to buy their $100 wireless wheel module in order to make stuff happen. The wireless wheel module doesn't do anything analog, though. This only does digital buttons. But we'll break into this protocol. I'm going to copy it and steal it. And then I'll have this $100 pair of circuit boards that just do nothing. The things I do for you, chat. The things I do for you. Okay, so where are we? We're on fourth gear. And third gear is there. Fourth gear is in the right spot. So let's move the cursors just a little bit. Sneak them over. Sneaky sneak. I mean, the consistency that I've been able to achieve just with our slapdash code is pretty nice. What the fuck? Wait, what are you? What the deuce? Okay, hold on. Oh no, we already moved that one. But like, where's this one? What? Ah! Wait, that's second gear? Old second gear is new fifth gear. Old second gear, 6. Okay, we found it. All right. So even if somebody has encryption, you can brute force it by mimicking the signal based on action produced. That's tough. We tried to do that with a pair of rudder pedals that the Russians made. I was hacking Russian code before it was cool. I had a set of foot pedals that were nice and minimalistic. We need to get back to that project, actually. That's for my joystick setup. The mount for the steering wheel actually came from that old setup. The 2 bars that clamp to the side of the desk with a bar in between them. I use that for joysticks, so you can have 2 joysticks, or joystick and throttle. I want to unify all that stuff together and make it one device. And we kind of stumbled on that because VKB sells these wonderfully minimalistic pedals, right? They're foot pedals that just sort of push against one another, right? Archive footage. I knew the PP with the keyboard would be popular. I added a couple BTTV emotes so that chat could have a little bit more fun. All right, anyway, so the VKB pedals, we were trying to reverse engineer, and I made all these Arduino programs so that we could look at the 1s and 0s running around. the way VKB wants you to have, they want you to be in their environment. They sell a little orange box that plugs into USB, and then you plug your joystick or your foot pedals or whatever into that and unify it under their wing. But I had a bunch of different products, so I wanted to use all those together. The foot pedals they made speak this ridiculous system. So on the changes in angle for just like 180 degrees, we were looking at the data and it was just madness. There were like the ones and the zeros were opposing one another. It turns out what they did, and this is like a major breakthrough because I spent like a week or two just really crunching my brain trying to figure out what the hell is going on here, because there was no consistency at all in the signal, which is weird. It's really weird that that would happen. Turns out they took their signal, doubled it, and XOR'd it together. And so bits changing had a totally different behavior to them. It was very strange. So once I unXOR'd your data, unXORs your data by literally just by putting it through another XOR gate, that unXOR'd it, and we've suddenly got a packet that made sense, except that the whole 180 degrees thing was still a little confusing. But basically in an Arduino, what you can do is you can tell it to get signals, right? You can have it listen in on that serial line, and then you can start playing with the data and pooping that out over your own serial connection to the Arduino. And it's as free as whatever code you want to write. And so we did that with the steering wheel, but in the sense that we wanted to fool it into thinking that it was connected. We will do that to the serial protocol of the buttons on this thing, but there's going to be multiple different lines that we have to observe. So we'll look at it on the scope first, and then we'll get to the other stuff on there. But yeah, the encryption in the case of the Russian pedals was an XOR. If it was anything more complicated than just that, I probably wouldn't have been able to figure it out. That might not have been an option. It's just encryption takes all kinds of different forms. I don't see the need to encrypt stuff if it's on your own line. I think the only reason VKB did that was so that people couldn't hack it, which is ludicrous, because it was just an ATtiny85 and a little magnetometer doing the angle. So we could just reprogram the entire ATtiny85 to do whatever we wanted it to. But it was such a curious, weird thing that it was just so weird and curious. And I'm like, the Russians tried to keep this secret. That was their flaw. And so we had to decode it. How'd you come to the conclusion that it was XOR? The behavior of the bits that are going through. I was looking at big sheets of ones and zeros and seeing how they behaved. And it seemed like every time one bit would flip, another would flip in kind. It would always oppose. And so the mirror image of the signal appeared to appear. And so it's like, wait a minute, that looks like an XOR. And so I just tried it. You just try it. You just see what you can do. There's a lot of studying of ones and zeros on that project because it was just so whack. Hey, when you get into reverse engineering, that's kind of what you do. You look at the code, you see the pattern. Yeah, that's how it works. The sixth gear, and that should be, hold on, that one, and then we'll just do a little one on each. This is like the most simple thing that I could possibly be doing. Sixth gear, 1, 2, 3, 4, 5. This would be this one. That looks like it's in the right spot. Okay, sixth gear is good. Bop. That's pin number 7. Seventh gear. Looks like it's in the right spot. And then 8 is clearly wrong, but I think we just corrected it. All right, let's throw that in there. Let's throw that in. Pattern seeking is one of the skills that have been sought after in code breaking. Wait, what did I do? What did I mess up? What did I break? What have I done? Wait, how come that's broken? Wait, what? Huh? Oh, did I not? I didn't. Yeah, oh. 5, 9. Wait. What? Wait, what? Wait, hold on. What? Pin 7. No. It's I got it. I got it. Don't worry about me. We haven't used 5 yet, so 7 is in the right spot, which means the one that's left. 2, 3, that'd be 4. Okay, now let's upload it, and hopefully this will make sense. Upload. Beep, boop, beep. Beep, boop, bop. Boop. First gear. Second gear. Third gear. Fourth gear. Fifth gear? Not fifth gear. Sixth gear. Seventh gear. 8 gear. So we need to swap 8 and 5. God, how am I still getting that wrong? 4, 6. Try again. Have enough gears there? It's enough for the Gifu. Do. Bop. Reverse. 7, 6, 5, 4, 3, 2, 1. Ah, there we go. Got him in order. Yeah, the Gifu, the poop truck in my summer car. Shame on you for not knowing the name of the vehicle. All right, cool. Well, shifter works. Low and high can be done with the steering wheel button. I didn't want to put like another button on this thing because this takes up exactly 1 byte. So I don't want to expand this to have more than 1 byte. Experience. What about your experience? You go experience grass or something, or whatever the kids are saying these days. All right, so that's the shifter. Now keep in mind, the OpenH shifter project, this thing is actually backwards right now. Whoever created this figured that the shifter should sit basically almost in first gear, right? But my shifter in my car, I have to pull over to the side significantly in order to get to first gear. So I actually reversed this whole thing. But it works. And the only reason it's hopping around on the desk is because I haven't mounted it to anything. Okay, shifter works. It has usable data on it. The microcontroller is kind of out in the breeze. That's okay, though. I have a mounting system on this. I have 2 little rail mounts sitting under the shifter. They're the kind that cam out at 90 degrees. So what we can do is we can mount this to the steering wheel. We can get the steering wheel up here on the desk. And then I'll have like the whole system together. The only problem right now is that this thing isn't sticking. Hold on, let's get the scope out of the way a little bit. I kind of want to add a header over here so that I can plug in my own like LIN monitor. I might do that in a bit. All right, so get this out of the way, and then this thing needs some VHB tape, I think, on it. The circuit board isn't really sticking to the Velcro, the temporary solution Velcro. Where's the VHB tape? VHB, this stuff is like nasty. This is nasty stuff. Keeper of maps. Another entry in the BTS queue. Yeah, about that. So yeah, basically what happens around here, those of you that don't know, because people haven't really like, man, we haven't had BTS in too long. I was telling somebody last night that like, it's been too long without burning the subs. That's the project we're working on next. We're gonna focus on it so that we can actually get this fucking thing working, right? There's a big board on my wall, with more boards in front of it. But this big wooden board on my wall, the purpose of which is to have the names of subscribers burnt onto it in a reasonable fashion. So it's basically Raspberry Pi will grab the sub event off of the Twitch API and then turn it into text, randomly try to place it around the board, and when it gets no collisions, mark it in a database, turn it into G-code, then actually stream code to a laser controller that'll then move the axis around and burn the name up on the board. So how long do you think it'll take to burn the queue? I have no idea. I haven't looked at the queue. I haven't even tried to compile the queue. You guys are all in there, but I can get a list of subs, or I can go through Streamlabs and just entry by entry do it. It's going to be a lot of clerical work, and I'm too worried about taxes right now. I got to do my local taxes still. I hope that doesn't take very long. I don't know what's involved. I didn't make enough money to do federal taxes, but I did. I made more than $1, so I have to do local. I say local, I mean state taxes. And they're gonna want a couple $100. They did last time. Yeah, it might be just the span of one stream to burn all the names. I think burn the subs is gonna be a lot faster when we're done. I think it's gonna be quite sped up. Just because it's not because of Clipper, but because of the higher power laser and the faster control of things. I don't know. Determining a maximum speed is going to be tough. Maximum speed that won't burn out the motor controls. I'm trying to peel off the plastic on this damn tape. Good old taxes, I know, right? I don't know if donations count differently for state tax or not. Oh boy. You guys want to have a do my taxes stream? Is the scope slowed down? So the way the scope works is you have to think about traditionally how these things were put together. So traditionally in an oscilloscope, you would have a vacuum tube, and that vacuum tube would be a mesmerizing stream to watch all the names burn. Yeah, that'll be fun. Mostly because I don't have to think. In a traditional scope, what you have is an electron beam. You even like, hey, Groovy, 40 months, Groovy something. Someone said maximum speed, so I showed up. How you doing? You can't say those words around him. He'll suddenly pop out of the furniture. Traditionally with the scope, what you have is you have a phosphor on the front of a vacuum tube screen, and that phosphor reacts to an electron beam. That electron beam makes a dot right in the center of the scope. And if you take a magnetic field, you can move that dot around. But it's always just a dot. That phosphor doesn't really dwell all that long being illuminated by the electron gun. So what you do is you magnetically control that line so that it goes across the screen. And when you put that line across the screen again and again, and you put certain electronics into it to make it do that, you can adjust the frequency that it goes back and forth. Then, if you control the vertical by making the vertical controlled by a voltage level going into the scope, you then have voltage over time. And what happens with that voltage over time is it starts to overlap itself and it makes trippy patterns. So you tune that frequency of the back and forth so that the line is in phase with itself, and then you get like a sine wave on the front of the screen. We're going digital. We're going ones and zeros here. So as we go with ones and zeros, those are all overlapping and everything is chaos. However, we have a trigger. And so if you trigger the scope on some kind of a signal, it'll stabilize itself and hold things still. So it's not that the scope is going slower, it's that it is overlapping a repeating signal again and again and again. That's the magic of the oscilloscope. I finally got the paper or the plastic off. Hey. And of course, that's also how vacuum tube TVs work. They have an electron gun that fires on different phosphors. So your CRT TVs have such a good refresh rate. Well, not really, but still. I try to use VHB tape to get this thing to actually stick, because the rough. Where else would you learn this shit? Google. You look it up on Google. God damn it. But yeah, it's this is a digital scope, but we're not doing like a singular. You can do a single capture of a signal. You have to mess with the settings. So if I put this on single capture mode, and the trigger pin slipped off. Let me put the trigger pin back on. Trigger pin back on. So that trigger is set off by the microcontroller in just a spot in between the signals, right? So, oh man, that was a tough burp. If I hit single trigger mode, that captures one signal. So this is not overlapping. This is not a time. Well, it's not overlapping. And so if I change the values of anything, this isn't plugged in right now, but if I change the value of anything, we're not going to see it because this is just a snapshot of what's going on. So when I run it, that runs, and now we're looking at multiple of the exact same signal coming in over the course of microseconds. I mean, this is a 5 milliseconds per division of this thing. So 5, 10, 15, 20, 25, 30, 35, 40. It's probably a logical number. It's like 100 milliseconds from end to end on this thing, probably. Wonder if the old Soviet-era analog scopes are still useful. Maybe. There's wear and tear. Like, the vacuum tubes don't last forever because they're like light bulbs. It's probably well out of calibration. But in terms of looking at a cool wibbly line, yeah, they're probably pretty useful for that. We used to have a bunch of vacuum tube oscilloscopes. I got rid of them. Shouldn't have done that. That was a long time ago, though. That was like 5 houses ago. I am old. I am ancient. I am very old. All right, so what are we doing? I want to get the steering wheel up here so that we can look at everything at once. We can go, hey, that's pretty cool. So let me turn this system off, and we'll get this thing lifted up. I also have to go pee-pee, so I'll be back in just a sec. Hold on. Let's put FTL music back up. I told you guys I was hydrating today, and I'm not lying. I'm not lying. Setup. Where's BRB? No, it's not in setup. That's relays. I struggle to find BRB for some reason because I don't use it that much. What's an interesting and dynamic thing to look at? I don't know. There's not much. Nothing's moving, so this is why I wanted to do that, the tourbillon mechanism, so that I could have something that was like moving that said BRB on it. I want to get back to that, but I don't know when I'm going to be able to. All right, I'll be right back. I gotta go piddle. Yeah, it's good to have those decoding abilities, right, that the digital scopes have. I have an analog scope here that was sent in, and I'd love to take a look at that. We just haven't had time. I've had too much of this stuff. Too much of this stuff going on. Scopes are fun, though. Oscilloscopes are fun. They're a very useful thing around the shop. Helps to have one. The prices for them are going down. because all of the technology behind the scope is really easy to get to, right? It's just the certification of the precision that you're really paying for. Some of them are baking in really nice features these days, though. I was looking at some, and they're all, there's like a $500 tier of scope that's really, really good. So I don't know. I would like to get another scope that has like an output, so that we could put that up here and you guys could see it much more clearly than me training the camera on the scope. It's still fun to train the camera on the scope because then you can see me fucking up, hitting all the wrong knobs and stuff. But still, it would be nice to give you guys like a nice real-time view of what's actually happening. I've had to, you know, this scope plugs into USB. There's always one. There's always somebody in chat. There's always somebody in chat who goes, hey, you could, you know, you can plug into USB on that scope. You got Ethernet on that scope and USB. You can control the scope. You could get the readout from the scope. Yes, you can. It is 1 frame per second. It is not acceptable for the type of stuff that we do around here. We reverse engineer stuff, right? And as such, we need to be cognizant of things happening very quickly. God damn it. There's always one. Soviet tech is easy to find, is it? I don't know about the dirt cheap part anymore. God damn it, there's 2. All right. All right. I feel like total ass today, by the way. I just like feel like shit. But the more we work, the better I'll feel. So let's get to this stuff. I want to move the wheel all the way up here. I'm considering whether or not I want to use this as the e-brake, by the way. Really? The first thing you're saying into my channel. You guys suck. All right, anyway, fucking assholes. Let's plug the whole wheel in. I want to get the whole system together here. It's going to be a little bit discombobulated though, because this table is 30 inches. The other one's like 27 or something like that, or 20 or whatever. So the heights of things are going to be a little bit off, but it's whatever. We get the wheel up here. Everything will look cool. The only problem with moving the wheel up here is that, unfortunately, I have to readjust the clamps to be compatible with the thicker desks. With the big, thick desks. You guys like thick desks, right? Thick desks. Thick, veiny desks. All right. Unplug this thing back here, which is the servo. Wait, why is that twisting? None of that should twist. What the fuck? Hold on. Is this thing getting loose? What are you doing? How is this able to twist? What? Oh, because that's loose. It shouldn't be. That should be nice and tight. We're going to run into problems with the cables breaking if this thing isn't tight. What can I use to tighten it? I need like a little wrench. All right, I'll find a wrench in a minute. I thought I tightened the shit out of this thing. I don't know why it's loosening up. Probably just use over time. So I'll put this over here and we'll move this. We still need access to this controller pretty much universally throughout this entire project. So move that over there. This I will keep right here for now with the other shifter. I don't know if I can fit both of them in the whole system. So both of these things. And then bring this over here, this heavy piece of shit that I like to call my steering wheel. I need plenty of backsplash space though. Oh boy. Totally and completely disorganized desk. Enters the chat. Hoop. So many things. I still need to fix the readout on my milling machine. That's been holding up the new camera project. Well, new old camera project. Holy fucking shit, this thing is heavy. Ah! Get that under there. I can just rest it here for now. But what I need to do is adjust the little plungers on the other side of these clamps, because otherwise they're not going to fit. Actually, they might. Nope, definitely not. Well, they do barely fit, but I'm definitely not going to be able to close them. This needs to move out of the way too. I got to keep a hand on this, otherwise it's going to fall forward and blow my foot up. It'll literally explode. Come on. It's not the most convenient system in the world, but at least I can unhook it from my desk, and then I have a desk. Come on. Trying to get it as far over that way as I can. That's not really sliding because it's got silicone rubber pads underneath. Push that in like that. And then these don't close when I put it up here like this, which is concerning, but I think it'll hang out because those have a little bit of clamping force, so it doesn't look like I need to adjust them, which is good. All right, here's the steering wheel. Some of you may remember this setup. Okay, so that's that. Now I get to organize all the bullshit that's behind it in such a way as to allow us access to the things we need access to, like the wireless wheel module. So this is going to be a little bit cleanup and a little bit of rearranging. Man, I need a nap. Fuck. All right, that there. This thing here, that's good. We don't have our trigger pulse if that scope probe is all the way over, but we'll deal with that in a minute. Let's get all these cables out of the way. Come on. Why is this USB socket like this? God damn it. Ugh, there we go. Jeez. It's like completely impossible to unplug, and I don't know why it's like that. We shouldn't need to reprogram the Pro Mini, so I can put the programmer away. The programmer. We'll get the rest of the system all hooked up. Probably should get my office chair over here and hook up the pedals too, so I can actually get the leverage that I want, so I can see that signal on the output. We'll have to reprogram the microcontroller for that, and then we'll take a look at the serial signal. So this is like the final setup for the whole system, which is good to do. It'll be a lot of fun. Fun. You guys remember fun? These wires and stuff, all these headers. All this stuff has to go away so I can get a little desk space. Big desk energy. I guess I can plug in this USB cable to program the main controller, main piece of this whole thing. Move the oscope back a little bit. We'll be probing around with it in a minute. And that's my LIN bus. And then, God, I gotta like scoop up all this. See, the thing is, like, there's nothing to trigger the LIN bus on. I mean, I guess I can look for a particular address, but the scope doesn't allow me that type of thing. I can't get I can't have it interpret the serial signal and then figure out that it should stabilize the display, right? So what I had to do was, on one of the microcontroller outputs, I had to output a little pulse that would then stabilize it in one particular spot. I could have it trigger on a timed pulse, right? You'd easily do that, but then it's which one of the 4 pulses that have that same exact time pulse does it choose? So you need to tell it to like look for an address and then stabilize there. And this scope, I don't think is that good. I don't think it can do that. So I just added a pulse. All right, there's all the trash off of the desk. All right, so let's put the shifter in here. So let me see. I can actually just put the pedals on the ground for now. These have to go here. What was that loose noise? Pedals there. Yeah, it's a little bit of a tall setup, huh? And having the pedals be directly right there is probably not ideal. Usually the steering wheel is a little closer to the driver. These will go under the desk, but I don't have a lot of under the desk for them to go here. It's like that. It's like driving like an airport shuttle or something. Driving like one of those dinky little, some kind of car that you'd stand up while driving, huh? That's cold. Well, I'm quite warm, actually. All right, let's see. Bop, bop, bop. This guy right here. I can release. Oh no, that's too big. Too big. What's going on here? All right, this one. So there's just two big hex bolts under this thing that I can just remove it from the rail with, and then I can put it on this rail. It probably should be a little further away, huh? Nah, I guess it'll be okay. It'll be okay if the microcontroller is hanging out the way it is. So in like this, just loosen it a little bit. I forget if I put plates or cleats on this one. For all intensive purposes, it should be cleats. Yeah, it is cleats. Okay, so these little cleats are very annoying. When you work with them in frame rails, what you need to do is you loosen it a bunch, and then you quickly tighten it, and that sort of makes it turn. And then it'll grip, but it's always kind of a weird thing to get it to actually work. Now, technically, I could put the shifter ahead of the wheel and have room for the other thing back here, the Steptronic shifter. Although this does take up a lot of space, but nah, those levers would get in each other's way. I don't think that would really work out. I was thinking about having this thing as an e-brake, but that's not a great idea. All right, so loosen. Tighten. That holds that there. Good. Get in here. Am I on the thing? I can't even see what I'm doing. There it is. Loosen, quick tighten. Is that actually held in? Yeah. All right. So the shifter is kind of even with the wheel, which is a weird setup. I have a friend who has a massive shifting like stalk on his car, and it actually puts the shifter basically here in regards to his wheel. It's a Integra, but for a sim, this is fine. This is fine. All right, that's that one. Next, we need to hook this thing up. So we need to get our LIN bus all the way over to this. I'm wondering if my knee is going to hit the electronics on this when it's set up on the desk. Yeah, it's like a giant stalk, I guess. I don't know what to call it. But it puts this shift knob like right here. It's very weird. It's very strange. I don't know if I could get used to that. Build an e-brake with a nice powerful spring to mimic the feeling. Where did that thing go? What did I do with it? Wait a minute. I had it out. It was around here. I have all the hardware for an e-brake. What did I do with it? Hold on. I'm looking around. I don't see it. I don't see it anywhere. What the hell did I do with that thing? I have an e-brake. It doesn't have a cylinder in it. Used to, but I could basically do a spring and a load cell to mimic an actual e-brake, but I don't see it anywhere. I don't know what I did with it. I was messing around with it, trying to see if I could incorporate it into the setup. It turns out those rails down there are too close and they're too far away. Wait, that doesn't make any sense. The rails are too close to one another. They're too near the center line where my feet are supposed to go, and they're too far away from where an e-brake would typically be mounted, so they don't work. Where the hell did it go? Oh my God, I lost it. It's like a big piece of aluminum. It's not something that's so easy to lose. I'm looking around and like the places where you guys aren't allowed to see. I don't see it anywhere. What the fuck happened to it? Wow, that's weird. That is weird. Maybe I put it like back in the storage area or something, or it's sitting on the shelf in the other room. It's just strange that I would be able to like misplace something so large and full of metal. I didn't throw it out, I don't think. Where else it would have gone? Huh, strange. All right, anyway, back to this. Let's see. Keep looking. No, I'm not doing that. God, misplacing stuff really bugs me. All right, hook this thing up. So we are now back to the distribution thing being under the wheel because we need multiple hookups up here. So I will take this, break it apart, and relocate it. So I can take this one out and then plug the direct one back in. Which is, which one? Which one's coming from the controller? Hold on. Hold on, we'll get there. We'll get there. That one is our power supply bypass. Here it is. This one is the LIN bus. Take that and plug it in internally. And this goes underneath the wheel. And it has a little plug that goes into the back of that. Here we go. I made a female to female adapter for this. Basically just two sockets soldered together and then shrink wrapped. So that's coming in from behind. Comes in there. This one goes out to the wheel with the slip ring. That Velcro's in place, but we also need another wire. And I need the wire to reach from the wheel all the way over to the shifter. Which I don't know if I have. I don't know if I have that. God, these things are getting caught on everything. All right, what lengths do we have here at our disposal? 3 wires. 3 of them. Looks like this one is the longest, but I don't think that one reaches quite far enough. I might have to make another one at some point. Let's see if we can just get it to reach over there. Man, there's a lot of dust under the wheel. I guess that's where dust collects and I can't wipe it off. Yeah, so I guess that'll make it, but it's still a little hinky. Hiding, you know, disguising the wire on the rails is going to be tough to do. Hello? Please plug in. There we go. That, and then this will take some kind of a run like that. For now, I guess it can dangle, but I will need to put that up on something. Put her up there. I can just take this piece and put it up top, and that'll hold that in place. I just need to get this out of the rail, which is tough to do. I need a tool for it. Special tool, which is just the hex wrench. Break it out. There we go. And that goes. We'll just staple that there for now, as a work in progress. Okay. So far so good. We've got the LIN bus accessory hooked up. I still need a monitor pin. Well, we're not really monitoring the LIN bus anymore, so I guess I can leave it out for now. I will also need something that connects to the pedals, so that'll be this one here. Although I could actually use a shorter one in this setup. I made an extremely long cable to hook up the pedals because I thought that they would not be part of the system. They would be something that gets disconnected and moved around separately. But the pedals are a great place for me to put the control box now that they've expanded so much. They're no longer just a little Fanatic set of pedals. They have this floor plate and everything. So in order to work with the office chair that I have, I basically took an old keyboard shelf and created. Here, you guys, where are you guys? Herc. I took an old keyboard shelf and I turned it into a floor plate, and then that holds up actual car pedals. So I can also put the control box somewhere on this, and then it'll be just a 2-part system, wheel, pedals, but they both will weigh a shit ton. God, this thing weighs a lot. It's really annoying to deploy. Fun to use, annoying to deploy. But I'm caught. All right, I'll stand up. Code Rush, how's it going? Thank you guys for the raid. Ugh, okay, I'll let my legs rest for a minute. How's it going, everybody? So we're hooking up the system finally. We're getting the band together, getting the whole band together. This is my clip onto the side of the desk racing setup. We get to program things and kind of look at the different signals that are running around, and we'll do a little bit of reverse engineering in a minute. I'm probably gonna have to go to the bathroom again in like 10 minutes. So my body is a temple, corroded and falling apart. All right, let's see. So I can hook up the wheel pretty much fully. I don't know if we are gonna need the full wheel hooked up in a minute though. When we do the serial reverse engineering, we want the whole system hooked up. Yeah, right now, this is concerning to me. The whole system will kind of move a little bit like this because those aren't clamped. They're not adjusted to clamp. My body's a temple. I desecrate it as often as possible. Yeah, that makes sense. Makes a certain amount of sense. Now I'm just a mess today. Anyway, yeah, let's get this thing hooked up. Burp, burp, burp. So one of the cool things that I found in this system was these RF connectors, these DB style power connectors. Look at this thing. Technically it's a DB like 15 kind of enclosure, but it has these big golden plugs on it. So we were able to hook the wheel up, the 3-phase wheel, 3 phases, 1, 2, 3 hookups. We're able to hook this up to the main control panel. You can also buy, although I don't think I bought a kit for this. Hold on, I'm hiccuping. Whew, ow. Man, that was painful. That was just pure pain, not even propane. These connectors are fairly modular. You can take them apart and get into them, and there were just big solder cups inside of it. You can also buy replacement connectors like this. The real savior of the whole project is being able to buy a kit for this one, because this one is not as easy to configure, and I don't think the ow, god damn it, that really hurt. Hold on. Fuck. You gotta watch out for these posts because they're not exactly smooth. They're not smooth like my brain. Yeah, these you can actually buy. It was like pretty cheap to buy a little kit for this industrial connector. These things are cool because they basically just have this little rotation that spring locks them in place. It's a nice connector. They use nice connectors on these things. All right, lock that one in place. Get this one on there. Man, that hurt a lot. I don't think I drew blood, but man, that was painful. All right. Righty tighty, lefty loosey, right? Oh, wait, there it goes. Man, this one's moody. It's being moody today. What's up with you? What are you doing? Why don't you cooperate? Oh, there it goes. Yeah, this is like an insane connection here. Super hardy. Robust, which is kind of a weird, indescriptive word. Yeah, overkill as hell. Pedal lover. You know your name is like completely banned on Twitch. I tried to put the word pedal into my freaking title and it was like, that is a banned term. Like, what are you talking about? Yeah, these are like big industrial connections. So hold on, I gotta get to the other side of the setup. Other side of the setup over here. This cable's all like twisted in a weird way. Here we go. All this stuff off to the side. We still have our bypass power connection connected. I'll have to unconnect that if we're powering the system up on its own petard. No tootling. Oh yeah, the Djibouti emotes. I tried to say, you know, setting up tuning pedals, or like tuning the pedal in the title, and it didn't let me. And then I had to allow that word with AutoMod a while back. I don't understand what the fuck Twitch is doing. All right, there's that, there's that. Here's power if I need it. I'll just plug it in for now. Oh, it's all the way on the other side. It's on the side that I don't want. Damn it. I think you guys are tolerating me today. Okay, there's that, there's that. We got USB if we need it. I'll get the chair over here and plug the chair in. Plug the chair in, and then I can actually like push on the pedals, and we can figure out whether or not the load cell is good or not, if we really need to do that. What I'd really like to do is be able to plug in the Arduino and have it say what's going on and display stuff like graphs and stuff. I wonder what I can use to do that. Do you guys know anything that does that? Do like a front panel with the Arduino? Hold on, let's see what I can find. It would be like what, like a numbers display or like a graph display or like a front panel, I guess. I don't think that's gonna find what we're looking for. No, that's not. None of this stuff is what I'm looking for. I'm looking for like something that I can run. No, I don't want raw data. I want that data to come back in from whatever packet I have, and then, yeah. How are you doing the wheel calibration? That's all handled within the CosmoQuest. The CosmoQuest is doing all of the functions of the force feedback steering wheel. That's what takes the signals from the computer and turns it into like a square wave or whatever it needs to do in order to give that force feedback. It's all within the CosmoQuest. That was sort of the silver bullet of the project. So what we're trying to do here when we get to reverse engineering is figure out what the serial signal is that will fool the Granite Devices controller into thinking that buttons are being pressed. So everything is just to fool this one controller, because some games can get a little squeaky about they get a little squirrely about whether or not one single joystick is plugged in or if multiple are. That's why I've been sort of trying to unify a lot of the different things around here. That's why we're trying to make this all just the Granite Devices controller. And there was a program that I ran called maybe FreePie or something like that. It was a Python-based system by which to unify all of your joysticks under a virtual joystick. So basically, we're trying to do the hardware equivalent of that to a degree. I feel like I'm gonna puke. I don't think I am, but I just kind of feel it. I feel kind of weird. I feel kind of weird. All right, none of this stuff is what I'm looking for. Front panel is the wrong word. What am I talking about? What am I looking for? Well, the reason that I clicked on this was I was looking for something that would enable me to create a digital like readout. It doesn't need to be the whole screen. It could just be like a little window that's readings from serial and giving me some kind of a readout. I don't know how to do that. There's probably something that I could just run that would do that, but I don't know the name of any of those projects. So what is like, I know there's a thing for this. I know there's multiple different like pieces of software that will do that. I remember there being one on Hackaday back in the day, but I don't know what the current one is. So like Arduino like gate, not, but if I look at the equivalent of what I'm looking for, like a gauge panel or something like that, I'm gonna find a physical project where somebody took a physical gauge and they hooked an Arduino up to it. So maybe like, yeah, serial readout. Readout front panel. No. Digital reads serial Arduino. I use Google Images just to make it a faster look. Aha! What are you? Data acquisition. DHT11 Arduino in order to get the temperature and humidity values. PC through virtual serial port. Program used to display the temperature and humidity values in real time. Borland C++. No, run away. Just run away. I don't want to program something. I don't want to involve cell phones either. What are you? Virtual panel. Aha! Arduino. Virtual panel. Now we're talking. Look at this. Look at this Chad. Look at him. Look at him. Oh no, he's off the... We've gone into cell phone mode. UI toolbox for experiment control. Writing only Arduino code. It's easy to set up control over experiments. The panel allows you to control from existing set of displays, LED buttons, sliders, and more. A button click or slider change causes an event in the Arduino code. I don't need that. That's a little further. Support experiments, making it quick to set up, control display output, text or a graph, second purpose prototyping, blah, 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 blah. How do I install it? Power value random, blah, 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 blah. How are they actually... Panel callback. I mean, you can make a processing sketch that looks at the serial monitor results. Oh, look, I'm bleeding. Yeah, that's easy. That's something that's known. It just takes a little while. I don't want to spend the time right now. I just want to, like, run a cool-looking UI. I have this, like, scratch on my arm, and every time I disturb the scab, I end up bleeding buckets. It's ridiculous. Like, how do I have this much blood in my body? Smells like iron. Technically, it's probably a toss violation for me to bleed, huh? Tell me, do you bleed? Okay. Panel automatically looks for virtual panel enabled Arduino board. So the question is, while it's doing this, I wonder if our serial signal is going to work out. It's not the first time I've heard, oh, look, I'm bleeding on this show. Yeah, I know. It's probably the same wound, too. This is the one that just, like, crops up and suddenly starts bleeding. What's wrong with you? Please heal. This might be a new scratch, actually. Yeah, it might be a new scratch. New scratch, who dis? I got all kinds of bleeding wounds. All right, let's download this virtual panel and see if we can do anything with that. Reduce blood volume with this one simple trick. Leeches hate him. Show in folder. Why are you not? Oh, there we go. Extract the thingy-majig. My God, look at it. C#. Oh, no. Dear God. Okay. It's got a lot of stuff in here. What do we need to do to run this? I may not even use this. I don't know. I don't know if I'm going to use this. I don't know. This seems like it's kind of annoying and complicated. It looks very useful, though. If I had learned previous to the stream how to use it, it would be very useful to give us just an idea, like a sense of all the inputs coming back in from this. A sense of pride and accomplishment, basically, is what I'm getting at. Features, generic functions, time, beep, reset file I/O. See, this would be interesting for making the brute forcer to try to figure out when lighting stuff occurs, because then I could just make a button that I can hit. Although you could just send it a serial. You could just like send it a command over serial to do that too. So maybe that's not so useful. Do I need to not download this? Is this maybe something that I just add as a library? Library manager. Although I could add zip library. Maybe that's what I should be doing. Hello? Oh, it's downloading the index. I haven't done this in a little while. Adding a library to the Arduino. God, it's going to be such a shit show when I move this all to the new version, because I have to move like Teensy, I have to move Digispark, I have to move all of the ESP stuff that I have all plugged into this UI, all the same UI. all plugged in at once. All right, so we're looking up virtual panel. Hello? Oh my God. What happened? Oh, there it goes. 3BC language. What? NVM? No. Virtual delay? No. Blink asynchronous? No. Wi-Fi manager? Button suite? That's kind of neat. Console? Oh, that might be useful. Dabble. None of this looks like the right thing. I looked up virtual and I got all this stuff. What is your project called? It's not Twitch. There it is. This would be called... Damn it. Scroll, scroll, scroll. Scroll, scroll, scroll. Look for the download. It's just virtual panel. It's all one word. Okay, that'll do it. Haha, there it is. Look at that. Damn it. Nothing. So is it, okay, all right. Hold on. If I need like C# or whatever to, I don't think I need C# to run this. I don't know. We could just put it to numbers. We can put it to numbers and we can separate the numbers by bars, and then those bars we can turn into graphs, all within the Arduino UI. It's just not going to be all that crazy. We could have put something together if I had done my homework and figured out how the hell to run this thing in the first place. I don't want to sit here and, you know, run my head into a wall over and over. I basically want to move on from this pretty quickly so we can get to serial monitoring. So instead of trying to blindly find my way through this, we'll move on and I'll just do numbers. But this looks like it would be a pretty useful thing. So I do want to come back to this, the Arduino virtual panel, because this is pretty much exactly what I was hoping to see. You basically can get a readout and then, you know, work with it. So we could figure out what that theoretical minimum and maximum is of the load cell. But anyway, we'll go to code something else. So what I want to do is go into the LinBus master code. So that would be LinBus main. This is where we're running everything. I am not in the mood to code today. I am not in the mood to code. What I want to do is I just want to quickly tune the pedals. So what we'll do is we'll go all the way to our serial output. So one thing that we are doing with the serial input for the analog stuff, what we're doing with the analog stuff is we're scaling it. We're actually scaling it around. This right here is how we're creating the numbers that we're sending over to the digital potentiometers. So we're taking all of that data and we're putting it into a packet, right? But that data has to be scaled because otherwise it'll be utter chaos. So somewhere around here, let's see, command, if register, digipot, 0, gas, clutch. Yeah. So these are the digital potentiometers and how we're controlling them. Now the digipot 1 will actually also contain the e-brake that we haven't implemented yet. So, but what I'm doing is a bunch of constrain and map functions in order to put it into numbers that are appropriate for the digital potentiometers. I have to use the bathroom though, so I'm gonna put up a BRB. I don't really have anything like worth looking at in the shop. Maybe I could just do face cam for a little while. I know that's what we're gonna end up using. I know, Hufo. I know about the serial plotter. I was just hoping for something a little bit more extensive, but what we can do is we'll just do a serial print and we'll just identify the three things. I'm not too certain about the range. It would be nice if they were all within the same range, but I mean the brake pedal we're mapping all three of them from 0 to 255, but like those ranges, like the gas pedal 265 to 844, 300 to 1023. So I guess what I can do is I can just comment these out. I'll take my scales. See, we're constraining that one to those values. I don't think we should be constraining them. So we can mess around with this stuff, or well, I don't want to damage. I don't think I'll damage any hardware by messing with this stuff. But like, we want to scale them onto a good range from those digital potentiometers. So what we're doing is we're limiting the data that we get back, and then we are taking that data, we're turning it into a range from 0 to 255, and then that goes into the digital potentiometer in order to describe how much resistance it keys in digitally. And so it looks like a potentiometer that's connected to the pedal. But anyway, I'm gonna use the bathroom before I explode. And then I almost locked this computer. I almost went Windows L to lock it. I'll just put up a BRB. I'll put on the music again so you guys know stuff is happening. And I'll be right back. And then we'll get into scale, you know, all the programming stuff that we need to do with this specific setup, so that we can observe it and then put it into something that's going to work in that system, and then we can take a look at serial signals. We'll start looking at what's running around. But I'll be right back. Give me a minute. Everybody behaving? I should probably brought my cell phone with me so I could do monitor chat while I was away. All right. I'm thinking about this serial protocol that we have to reverse engineer, and it is going to be complicated. I don't know what kind of initial handshaking needs to go on in order to get an entire Bluetooth module up and running with everything else. That's going to be complicated. I'm a little worried about what that's going to take. All right, so how do I do graphs in Arduino? I vaguely remember. That's all I remember. Just vague stuff. How's it going, Disc Company? All right, so how do I do this? Arduino graph. I'm just wondering how I separate the different fields. Blah, 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 blah. Wait, where is that? Oh, it's got a whole processing tutorial here. Oh my God, what the hell is that thing? What the hell? Going fine. Good. Hello, serial plotter? That's what I'm looking for, the plotter. So, serial print, yes, that's fine. If you got one number, it can do that. But it can also do multiple charts. So I'd like to have gas, brake, and clutch all on one chart. So, variable nth. So, okay. Wait, no, it has to be terminated. That's fine. We want to plot multiple variables. We need to separate the variables from each other by a bar T. The hell's it? /T? What is that? I think I could just put a bar symbol on it. Y1, Y2, Y3, Y4. Space, or, oh, T is a tab, okay. Bop. So you can just plot 4 numbers. All right, that's easy enough. All right, so let's get into the chart stuff. So we're doing all of this stuff, but we still have gas, clutch, and brake. Oh no, never mind, I'm overwriting them. So before I overwrite them, I would like to plot them as they are. So what I need to do, well, I need to find, so yeah, here's our serial print. Print wheel, print shift, print pedal. Depending on whichever one I've enabled, it will print the 1s and the 0s coming back. But we don't want 1s and 0s. We would like to have a chart. So if I take, oh God, this is where I put together the packets and stuff. I think somewhere up here, and probably the main part of the code, is where I tell it to print the wheel, right? All the way up here. Bus wheel, bus shift, bus pedals, blah, 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 buttons out, pin outs, serial prints. Serial prints, that's where we're looking for. So Control F, lowercase, serial prints. This is kind of a big program that we put together here. Serial prints, print pedal, bop, bop. There we go, I fixed it. So now what I'd like to do is just have it print the numbers from the pedals. So we'll just do that in a kind of a hacky way. We'll just go up here and we'll grab, before I do anything to the numbers, I'll just do serial print, and then we'll do gas, serial print, space, print, clutch, serial dot print, brake, just like that. Bam, wham, bam. Thank you, ma'am. Oh wait, no, I need serial print space. And if we really wanted to, we could make it human readable by putting in the last one. I'll just make it a print line. So serial print line break. So then it'll put a line break after that. And so if we look at our serial data on the serial monitor, it'll just be this rolling tally. Now we can name these, and I think the Arduino IDE lets us name them, but I need to remind myself about how that works. I see here. Maybe not. I don't know. I don't know. I'll just close this. All right. So, blah. We've got all our printouts there. That's just a little block of code that I inserted before we mess around with the numbers and ruin them. That should be all we really need. So let me plug in the Arduino and get our system powered again, our LIN bus system powered again, and then I can look at this stuff on a chart and figure out what the mins and the maxes are supposed to be or how the system even responds. I'll probably have to staple my my office chair to this thing over here, making even more of my shop completely impossible to get across. So let's just do it. Let's just do it up. Do it up. Do it to it. Oh, there's a magnet that I dropped like ages ago. Try to pick it up. Oh, nope, never mind. It's stuck to the lamp. That's fine. It can stay there. CosmoQuest rating with a party of 25. Oh my God! Sound the alarms. How's it going? We're hooking up our system here. The sim racing setup that I have. I need to staple my chair to the end of this bar, and that will allow me to press the pedals. And we can take a look at what the chart looks like on the Arduino IDE. Keeper of maps in both streams. Hello again, indeed. My chair. My gross office chair. All right. I got the gross office chair. We'll get it on a different camera here. Oof. I'm feeling like weird today. I think I might be a little under the weather. That or I just did it to myself by not sleeping properly. That's probably what it is. It's just bad sleep. So trying to take it easy, but still got to do this stuff. All right. So let me plug this stuff together. I need a wrench. I think it's this one. I think it is this one. I'm not sure. So we got a wrench. I got this thing, and then I have this plate that I've attached. It is actually for mounting a light bar to your truck. But it's you guys can't see it, but it's basically like a circular collar that goes around the piston of the office chair. Have you ever made an FPV drone? Yeah, I've got one sitting in the back corner of the shop. It just became a little too time consuming and expensive for me to work on, and I never got anything done with it. Lunatic Live, Louis, convinced me to buy this little FPV camera. So I do have a headset and a decent camera now. I was trying to make a system where when the drone went forward, it would tilt the camera up so you could still retain your vision. I got a cough. Give me one sec. Okay, that's a little better. So yeah, Louis convinced me to buy this little tiny FPV camera. With the RC car stuff, we still haven't even finished that. I'm trying to do a one-cell RC car that has the Tamiya motors in it instead of like a three-phase thing. But if I ever do get back to that, which we will, I would like to FPV that. That would be a lot of fun. RC car, it was my pandemic project, basically, was the RC car. What we were doing is, I saw Djibouti Show playing that Mario Kart home circuit, and I went out and bought it. It was kind of expensive, but it was really, really fun. And I raced it around a little bit in the shop, realizing that, man, if I could have a little powerful like drift car, that would be a hell of a lot of fun to just race around on the floors in here. So I built this entire RC car, and we sort of redesigned the speed controller and everything with the intent that I would circle back to the Mario Kart home circuit and put all of the advantageous stuff on that Mario Kart. Because that Mario Kart is just, it has like one gear. I don't mean like a car gear. I mean, it has like, or it doesn't have one gear. It has like a gear reduction, and then it has a motor on a one-cell battery. And so the thought was, if I could keep it within the same specs, keep it the same size, the same motor of the right type, one-cell battery behind it, we could make a faster Mario Kart home circuit kart, one that has suspension and a differential. We never really got too far with it, unfortunately. I was going to try to 3D print the enclosure for the whole thing. We were basically going to take Mario out, and I was going to put either, not Lakitu, Dry Bones, I think was one of the ideas was Big Yoshi, and then the other one was Dry Bones, because Dry Bones is who I typically Mario Kart as.
So we would put dry bones on it, and then I'd try to like put like a carbon fiber plate under it and everything, just like any advantage that I could possibly give it. That would have been fun, but it was a lot of project, and we never really got around to it. I had just built the speed controller, and then it totally fucking failed on me, or it didn't quite work right, and so I had to kind of like lick my wounds and come back to it later. All right, hold on. I gotta get these cleats to cleat. There's like gross stuff on my office chair. I think this thing fell down. Huh. Well, it looks like it's at a weird angle. Whatever. Whatever. Whatever, dude. I don't care. But yeah, it would have been really cool to like send that in to Djibouti show. I mean, if you wanted, you could cheat. You could cheat really heavily on Mario Kart Home Circuit. You know, you could put like a 3-phase motor on that thing. But I wanted it to still be like competitive. I wanted it to have sort of a different racing dynamic and still work with all the augmented reality stuff. Because all the people that made Mario Kart Home Circuit, their prototype was essentially a Raspberry Pi on the 1 to 28th, I think, scale RC car. These little drift cars. They're a lot of fun. I like that form factor. I don't know what everybody's up to in RC stuff these days. Hooking the bar up to the chair is the fucking worst part about this whole setup. It's the pits. It's terrible. And I need to make something that works a little better in this regard. I need to do like a pin that fits in or something. This thing is still not in there, is it? It seems to be. God, this thing sucks. All right, hold on. Topic. You just said topic into the... What am I supposed to respond with? Wanting to build my drone or hexapod from scratch. There's some really cool autopilot stuff out there that I was playing with. Some really interesting systems. You know, I had like Arduino and like a couple other things, but like nowadays there's probably much better stuff. I have a friend who actually got a recent DJI, and man, that thing's cool. Man, that can do cool stuff. He was sitting at the kitchen table and flying this drone out around the neighborhood. And like, oh, there's a kid on a bike. Let's chase him. Like, what? What are you doing? Oh man, these little cleats are so... I need a better system for this, guys. I need a much better system for this. For hooking this up to the base of the chair. Because like, this wrench doesn't fit in there. And the little 90-degree cleats aren't gripping right. Ugh. Setup is looking good. Hey, thanks. I wish I could make it hook up a little faster. I haven't messed with drone stuff in ages. Yeah, it's come a long way. Pixhawk 4. I've never heard of it. Tricopter out of spare wood. Yeah, if I were to do drones, I would be using just carbon fiber that I've got lying around and just like make something weird. Simple FOC library to build torque sensing RC steering servo. Interface it with the sim rig. Force feedback RC car. Yeah, you can do that. And you can do that with Mario Kart Home Circuit, actually. I'm not sure if I can plug in the Granite Devices controller, but I do know you can just plug in whatever. And I don't know, somebody was able to run some software. There's like a whole tutorial on how to do it. Maybe I did this by hand. I can get that to grip. Nope, it didn't grip. It didn't grip. The problem is I've got to hold up all the weight of this while screwing it in. And then I need to get that little cleat to do that 90-degree turn. That's hard to control. I need something that I can just sit on. And then I can tighten. Okay, that one's good. Yeah, doing it by hand initially is probably the meta here. You guys can't see it because it's under the chair, but rest assured, it is very annoying. tighten that so that it doesn't slide. It's basically just down to an aluminum angle iron, but I need to find like a better mounting system, I think. A way to make it a little less of a struggle. Like something that drops and locks, I don't know. Get out of the way. There. That was easy. Jeez. What's that? Not sure if there's an AutoMod bot. No, you're good. You can, as long as the links are relevant to what we're talking about. Put an IMU on it. Interface with my sim motion performance. Oh my god, that'd be weird. Scale rock crawling from FPV. Yeah, that would be kind of cool. I wish I had more of those linear actuators. I don't know, Trump Foreskin probably wasn't watching the channel that day, but he's been around long enough to have seen the industrial 3-phase linear actuator that I have, the thing that's worth probably like $5,000 that I got because it fell off of a truck. Actually, the packaging machine that it was part of fell off the truck, and then the actuator got scratched. So they bought a whole new one from Alan Bradley. And now I have one of these things. And if I had 5 more, or even 3 more, or 2 more, I could probably build one of those rocking motion sims. Yeah, no, not that kind of fell off a truck. I mean, it literally, like when they were unloading the machine hit something. And so, so what this does, the reason that I've got the keyboard tray here, two purposes, right? I mean, this will always feel like an office chair. It won't feel like a car chair, but part of the sim setup is that I need to be able to hook it up to the side of the desk. Computers are expensive, and I don't have computer parts lying around. If I did, we'd all be eating steak, but unfortunately, sourcing a new graphics card and doing the whole trickle-down graphics card thing around here hasn't happened in the past 2 years. So what's happening here is that I need to be able to attach this entire setup to my desk, my office desk, from where I stream, because it's the only functional good computer that I have. So I have made the giant, super heavy 3-phase motor mount to 80/20 rail that then uses Bessie clips to clip to the side of the desk. And so that makes a little clamping force in the 2 ends over here. This was originally a joystick setup. I have a different one for the joystick setup, and that one's made out of anodized aluminum. It looks a lot better. So that was the setup for a while, right? Shifter and pedal and wheel and stuff was here. The pedals I just threw on the floor and used just normally. But the problem is, like, this is not that comfortable. Considering ergonomics, right? Consider ergonomics, chat. If I'm sitting like this and my pedals demand my feet be at this angle, they are not comfortable. There's a lot of stuff going on when you get in a car, ergonomically. There's actually a lot of very interesting things happening. So one of the primary violations of that was having the pedals on the floor. And so what I would do, actually, I think we also mounted the pedals to this setup. But the problem is the angles were all wrong. It just felt wrong, and my ankles were tired after a little while. In addition to that, just to rest, I would put my one foot on the floor and have my other foot operating the gas pedal. It just didn't work. Like, the ergonomics were just terrible. So what I did is I looked up real car pedals. And so if I can emulate the way a real car feels, I will be much more comfortable in the entire setup. So this is what I have. I have the lid of my old computer. It's a steel grating. As the floor, I'll put that in quotes, as the floor of my sim setup. And then I've got actual car pedals coming up from above, angled with the car pedal angle, so that they're basically I'm looking at the flat part of the pedal. The gas pedal is almost exactly as it is in the car, although I think maybe I need to move it forward a little bit, because I think in more modern BMWs, they have this whole rubber piece around the brake pedal, which is kind of interesting, because remember, not too recently, maybe was it like five to 6 years ago, there was a big shakeup in the automotive industry because people were accidentally accelerating, and that became a big news story. And so the engineering follows, and so we have a very extensively engineered with redundancy gas pedal, our brake pedal has a piece of rubber on it that keeps you from catching your foot on the brake pedal. There's a lot of weird little touches that they put in there in order to avoid getting into another like lawsuit situation. So with all that stuff here, right, and all the ergonomics figured out, all the distances figured out, it still doesn't quite feel right. It still doesn't quite feel like a car. There's something missing. And what that thing is, it's all the way over here. Hold on, I gotta go grab it. I go all the way across the shop and grab this thing. What is missing is something holding up my thighs. And since I can't hire anybody to do that, I got a pillow. It's got a wedge pillow. It's just a little wedge pillow. This is the difference between an office chair feeling like a car or not. Yeah, it's all that idiot factor, right? But they keep inventing new, more functional idiots. So anyway, wedge pillow. Now, there's no side bolstering for my legs, and I refuse to buy one of those frickin' awful racing chairs for gaming. Those things are dangerous and annoying. The ergonomics of a car seat are not ideal for gaming. You want a regular office chair. You want ergonomics. But now, with that pillow holding up the bottoms of my legs, actually sitting in this like it's a car is a whole lot. This is completely different. Like, I can keep my legs like this for an extended amount of time. I do need to move the gas pedal back a little bit, but this feels more like I'm actually sitting in a car. So I'm actually really excited about the clutch and stuff. Now, I need to get longer arms. Okay, there we go. And we're driving, and then I change gears. So I put the clutch in, and all right, there we go. Okay, we're in a different gear now. Obviously, my legs will be far under this in an actual setup. I guess I can scooch forward a little bit. All right, let me adjust my seat. Well, now the pedals are directly under that, and this is still the least comfortable way to drive. You want your arms to be bent just a little bit. But this won't be the way it is in the desk. This is obviously the streaming, the shop desk is different from the from my office desk. Yeah, that feels very comfortable. I don't know how I got this distance correct, because the frame rails that make up this setup, the ones all the way on the outside here, those are a keyboard tray. Those were not specifically made for this setup, but this feels good. I can put a lot of pressure into the brakes too. So what I want to do is I want to get that reading out to the Arduino so that we can see how much force I'm putting into it. These DC gear motors and encoders for a 2-degree of motion sim. Super easy. Did you share that? I feel like I remember seeing that. I think you shared that in the Discord. It's pretty awesome. That system was badass. Okay, so with this code, I shall unite all of the clan. Now, with this code, we can actually see the values that are coming out of this thing. Now, one of them is 0 to like 1024. It's like an enormous number, but I can just turn on the LIN bus here, and then I can plug in the USB over here. We should be getting readouts from everybody, although we're not going to see it on the scope right now. We're going to see it via serial. Via serial. Oh, there it is. There's the cable that I was looking for. When can we see this in action? We got a long way to go, buddy. All this hardware is going to work, but the software that we need, because, okay, so Granite Devices, the Granite Devices controller, that's what rules everything here, right? The Granite Devices controller. The Granite Devices SimuCube is a system, well, I guess we could just use this right here. So here's what Granite Devices wants you to do. They want you to spend $100 on each of these. Now, the SimuCube isn't cheap to begin with, right? If you want to DIY your own wheel with your own 3-phase motor, this is the way to go. It's a really, really good system. It's not cheap. And then you need to do all the characterization of your giant 3-phase motor It's fun, and when you get it to work, it's brilliant. But Granite Devices did not include a ton of ways to get buttons into this thing. There are 4 Ethernet connectors right there, and those are designed to be able to take button inputs in directly from buttons. So they want you to string up a bunch of Ethernet all over the place. And we just observed that my whole system exists to be removed from the desk and added back to it. Not to mention the fact that I've made all of my peripherals speak LIN bus, which is not a button pressing kind of affair. So the 8 inputs from the shifter are sort of overdoing it for the number of buttons that I actually have active in this system. I have paddles on the back of the steering wheel, not to mention I can place phone calls and stuff. I got 12 buttons, 14 horn, 15. I can't really get to the horn right now. We need to redesign that part. I do like that it has a BMW logo, even though it's a Mercedes steering wheel. So anyway, this is 15 buttons. 15 buttons. 16, 17, 18, 19, 20, 21, 22, 23 buttons. 23 buttons. That doesn't have 23 inputs on it. Indeed, in order to get 23 inputs, you need to add this system right here, this battery-operated system. Now, my steering wheel has a weird way of multiplexing the button inputs. So if I were, by the way, this thing is not mounted perfectly. It kind of moves. It's a little janky. But anyway, my wheel is not. It's not direct button to microcontroller, right? It's actually multiplexed. So there's banks of buttons here, which mean I can't just hook. Which means I can't just hook this thing up to the steering wheel and then free up all those buttons. So what we have, the button needs all of the steering wheels. The buttons need the steering wheel, okay? You're getting it wrong. No, the steering wheel needs all of the buttons, okay? The reason I chose this one is because this is up, down, right, left, and OK button. Why? Why do you beep at me in the middle of a thought? Completely changing my thought train. I saw on Twitter today, I actually saw somebody, it was like, what are your hot takes on diabetes that'll get you canceled? And the person said, and this is an interesting take, that the mental tax of having a CGM with the constant monitoring and tweaking and stuff is not, it was basically like I've been living without a CGM, and I found that the mental tax of having it was too much, which is crazy, but I totally understand it. I don't know. My personal health and longevity is somewhat hinged on the CGM, because when I don't have it, my A1Cs go fucking wild. They go nuts. Anyway. Yeah, you can't have enough buttons with the simulator setup. And so what I'm trying to do is open up the field so that I also want to put this thing on there too. So this thing doesn't even have to fully communicate with like a game controller, because what I could, this right here, this analog value for the backlighting on everything. And so I'd really like to figure out what the packet is that will turn on the backlight on the steering wheel, because it's there, but trying to figure out the pinout of a multiplexed window mirror button module from a car right now. Yeah, you gotta like pull the whole thing apart in order to figure it out. This one's fairly simple, luckily. The E46 has, I guess, a lot of singular signals on wires. This is actually on a potentiometer. So a voltage level determines which of 4 modes you're in. Very strange. I guess they wanted to use one wire on it. Like all these systems that we've found for like the E46, anything newer is way more digital and nice. But like even the gas pedal outputs 2 voltage levels. Looking at a different HOTAS system. Yeah, HOTASes are great. I have a bunch of that stuff. We'll get back to it eventually. But yeah, I guess BMW wanted to like save the number of wires that they were sending around. All this stuff is like pre-digital. And man, it makes a whole lot more sense to go digital with this stuff. I know, the safety redundancy, I guess, is necessary, but still. All right, so let's get some values running around on this thing. But yeah, the whole point of what we're doing is that in order to add the extra buttons, I need another way to communicate with the CoSmoCube controller that a button is pressed. It has control of like 128 buttons. I think that's the maximum that Windows allows. 128 buttons, and this thing can control them, and it does if you buy these modules. You cannot digitally communicate to the Ethernet lines or to the pins that go directly to the microcontroller. You just can't directly communicate and tell it what buttons are pressed. I wish I could tell it the buttons. I wish I could tell it the analog inputs, but it doesn't let me do that. I really wish it did. And supposedly Granite Devices is talking about it, but talking about allowing us to get in there, but nope. 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 But yeah, we're gonna have to fool it into thinking that these are legitimate devices connected to it, which should be kind of fun. From your button plate manufacturer, huh? Yeah. PDF documentation, wireless, Gerber files. See, they don't. Oh no, I don't need that. They don't tell you anything about the signal protocol or anything like that. I don't know. I don't know if that's going to take the form of like a common serial protocol. It might, but yeah, we'll have to look at this and figure it out. I'm afraid of the complexity of the packets in there. I think there's going to be a lot of different stuff running around. So all right, anyway, we don't need any of this stuff. Let's get this out of the way. Let's take a look. Well, let's upload our code first. So I'm gonna go ahead and punch the Arduino with my code. Plug that into USB. Hopefully the thing's able to handle it. Upload. Oh wait, no, I didn't select the right thing. Well, good. Yes, set SDA as you have no idea what's going on because you're not an Arduino Pro Mini. You are in fact a Teensy 3.2. And we wait, and we wait, and we wait. Tools, 96 serial, faster, US English, blah, 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 blah. Now, the Teensy can be turned into like a peripheral. Like, we could easily just turn that Teensy into another joystick that's connected to the whole setup, and so I'd have two joysticks. But from what I hear from the other sim heads that pop into the channel occasionally, that it's actually like multiple USB devices are kind of like frowned upon by a lot of setups, I guess. So I'm trying to wrap it all into one. If I didn't have to do that, we'd already be done. We'd already be done. I would just run another USB, like I'd put a USB hub inside of this thing, and then we would just have the extra buttons report to USB that they're being pressed, and so we'd have the analogs could stay on the CoSmoCube, and then everything else just goes over to a new device, or the analogs could just be on the new device. God, that would be easy. Sigh. How do other companies do it? Like, how does Logitech do it? All right, so let's upload. Boop. Beep, bop, beep. Beep, boop. Bop, bop. Bop, beep, bop, bop. Bop, boop. Boop, bop, beep, bop. Man, this is putting a lot of stuff in there, huh? A lot of transmitting going on. Bop, bop, beep, bop. Damn, that thing takes forever. All right, there we go. Man, that was a long compile. What am I doing? What am I doing here? We're not really running. We're running MCP 230717 and then the wire.h. They just buy out the others. I'm talking about like, that's not what I mean. COM9 is not available. Use COM8. Why are you complaining at me like this? Weirdo. Those are our what was that giant value up there? 64, 619, 866, and 148. It's good to be able to see these numbers like this. Comcast Tech is outside. Wreaking havoc? I thought that was the opposite of what they were supposed to do. 99% sure the DirectX 12 only supports 32 buttons. You can expand. Well, I don't know about DirectX, but I mean, you can have 128 buttons on a controller. The Teensy supports it, even. Wish you would stop bleeding, you stupid little scratch. Okay, those are our values. So what happens when I push in the clutch? Yeah, look at that range. All right, so our our overhead is 866. And our minimum value, I can't see it from here. But if I take these numbers, I can actually go and just do a plotter. So tools, no. Yeah, tools, serial plotter. And there's our plot. Look at our plot. Look at it go. At least those numbers are very stable. Got a little bit of movement down here. But now I need to go and change, I need to go sit over here. Verpal? Not more than 32, but it's split up. Muxt software. See, I know of the FreePie program, and that allowed you to split it up and put it all back together, I guess. But I don't know. Yeah, I don't know. Is 32 really the limit? Because how many buttons do we count? We're at like 28. I know some setups have a lot more. But is it like the games don't support more? All right, so sitting down, gas pedal, yoimp, yoimp. Well, that is a very narrow range, isn't it? The brake pedal is skewing our values quite significantly. Clutch, all the way in, all the way out. All the way in, all the way out. Not a whole lot of movement on the graph. And when I hit the brake, we go into the negatives. Look at us go. So I have a maximum amount of braking force that I can actually put on this system. Actually, that's a significant amount of braking. Ah! Something made a cracking noise. Uh-oh. Made a popping noise. Oh, it was my 3D print. My 3D print unseated. Hold on, I gotta grab it again. This anvil is just sitting on the bolt heads. But what this is doing is keeping me from being able to brake, as in B-R-E-A-K, the bracket that I have down there. This is my backstop. Oh no, we're gonna have loud lawnmowers going by. Hold on, I have to turn off the motion sensing system. Oh, my friend is ever vigilant, texting me to say that a graphics card is available. Ooh, man. Not in a position to buy. If I get that graphics card, like, as in I'm on the air. Right, I probably already missed the opportunity. Yeah, if I actually get that graphics card, that's gonna spring a whole bunch of projects. There you go, disarmed. Man, that was a tough screen to get to. Ring really needs to reconsider how they've put together all of their stuff, because it's annoying. Okay, so we need actual values from this thing. So we need to see what numbers we're going in between. So you guys remember 64,620. We'll do 64,620. Here, let me just make a note on that. And that's basically what I did before anyway. Let's go down to where we actually have our serial prints, because that's right before we scale everything. So once we get it all scaled, we can then scale it over to 255. But down we go, down, down, down. Here we are. So, new notes. Who dis? So the break 64,800 becomes 64,620. And then our next value is whatever I get from pressing down on his bish. So let's press down on the beast here. Let me get my full braking force. I gotta automatically put in the clutch because otherwise it doesn't feel right. 51,500. 51,300. That's tough to press in that hard. Like this would put me into the windshield. 51. God, at 50, I can get it down to 50 if I really press in. We'll do 50. 50 with 3 zeros, and then I can scale that in software, like in other software later. So 50. The previous value was 59. Look at how much different. Look at how much more force I can put into the pedal. I'm powerful. All right, next one. This is the fun stuff. This is like the fun stuff in the project where you can actually characterize stuff. I don't know why that one's starting at 148 for the gas pedal. I guess it starts at like 0.4 volts or something, and then it goes up to just about 5. So the gas pedal is the most stable thing ever. This is ridiculous. Like, look at how stable that is. And I could count it like almost by individual numbers. God, there's like no noise on it at all. I wish my entire system could be made out of these gas pedals. I'll just buy 3 of these things and just put them right next to each other. That actually would work. That actually would work pretty easily too. It'd be nice and stable. So 825. I mean, we can get to 826, but it's the only way. It's like actually not stable. Oh no, wait. No, 826 is stable. I'm just weak. So 148 to 826. Now the load cell, I don't know why that starts at such a high number and goes down. I think I may have put it in backwards or something. I thought it would start at nothing because there's nothing resting against it, and then go up. Weird. Clutch. A clutch pedal's up to the magnetometer. That is a Hall effect sensor. It's gonna be a little weirder. Let me close all these extra Arduino windows, by the way, just so I don't get distracted by them. So we're starting at 866. And we are ending at whatever the max is. Now I need to put my foot on it because we put a new spring in here, and it's much springier. 193. So 866 to 193. This feels, by the way, this feels good. These pedals feel like driving a car. I am excited about this. So those numbers we're just going to put in. So we're going to constrain the gas. Well, 265 to 8. Wait, how is that number? Oh wait, no, that needs to be this number. Yeah. So we're going to constrain the values. I don't really think we need to. I don't really think we need to constrain the values. I guess this will just make sure that everything, when it's scaled, doesn't overrun and suddenly become the opposite side. That's sort of the purpose of constrain here, is to keep the binary number from looping around and suddenly having a really bad effect. Why am I crouched like this? I don't know. So the gas, we were constraining 148 to 826. I'm just doing this manually in the code. I mean, the really good way to do this would be to do this with variables, to actually use variables. 50,000 to 64. 64. Yeah, 647. We'll leave that 5,000 to 647, and then clutch. We are constraining from 192. 9. Hello? Keyboard? There. 195? Nah. Yeah, 195. Nah. 193. How about that? Yeah, you don't know what to do with that number. And 866. Why am I like guessing on the keys that I'm pressing here? 870. I'll just round them up to the nearest, whatever. Oh, these should be lower, actually. So, actually, 190... 191. That's a weird number. I don't know. 148, 826. I guess we could just put in the exact numbers, so that shouldn't really affect it that badly. That way we know that we can hit the max. I mean, the numbers are so stable. We'll just use them. We'll use them directly. So then what I do is I map them from 0 to 255, and you can flip these around and get the ranges to actually be like low to high. It'll flip them around on the scale if you program them in properly. I'll actually sit down. Audio went staticky. Ah! My positioning was weird. Sorry about that. Okay. Oh, that looks like it's still staticky. Hold on. This is a movie quality lavalier microphone, and it's hooked up to a board that we made going into the audio system, and then through some filters, some VSTs that I have loaded up into OBS. Sorry, I'm hiccuping now. Now I'm hiccuping. I wasn't hiccuping before. That's fun. Fun. Thank you. But yeah. Depending on my body position and stuff like that, like my beard will rub up against the lav mic and that'll cause a bunch of interference. Or I just think one of the audio lines is a little different. And if the differential thing inside of the Focusrite takes the wrong one, I think it also gets staticky and weird. So I have to like unplug stuff, plug it back in, and just like jiggle my body around, and then everything works again. All right, so what are we mapping it to? Well, 0 to 255, right? I could do 255 to 0. We'll make these consistent once we get to see the outputs on them. So what I'll do is I'm just going to plug the numbers in as they were. So low to high, low to high. So 148. Yeah. 148. 2826 is now given 0 to 255. So 50,000 to 64,620. 420,69. 620. These, you don't, sorry. I made a whole bunch of weird noises just then. 866. What are you talking about? Was it 866? I didn't think it was 866. Where are you getting that number from? Oh yeah, that's where, I'm looking at this one by accident. You were correct. Got two 800 numbers on here. Just from the Arduino, sorry, the ATtiny85's analog reads. I guess they like that number. It's just 66. Okay. You don't really need to, you know, this type of scaling and stuff. I don't know how necessary it is. But with like the load cell, it's funny that we're taking a 10-bit number and we're whittling it down to 0 to 255. It's ridiculous, right? But we're not really going to sense that granularity. I think Xbox controllers now do 0 to 1024, which we could probably do here, but our digital potentiometer doesn't have enough positions to really represent that fine of a voltage swing. We could put two digital potentiometers into one another. I wonder if that would allow us to have, what would that circuit be like? You do like, you wouldn't really do them in parallel or in series. How would you do that? I wonder if you can up the resolution by doing that. Anyway, whatever. 64,620, 0 to 255, and then we got 192. I got better resolution out of this whole system now. To 86, well, that doesn't. 866. That one doesn't. It doesn't go all the way up. Oh well. Good enough. Good enough. So those are our new numbers. Now we want to actually check over those numbers. So what I'll do is I'll just take my serial prints, cut them, and we'll put them down here after we get the scaled output. So now all three are going to be on the same playing field, and we'll get a much better chart readout. They have really improved that chart readout. It looks much nicer from the version that we used previously with this system. I mean, it looked nice. Yeah, I love doing this kind of stuff. I love doing this kind of like sciencey stuff with Arduinos, like where we're using it as like a data acquisition device, and then we you know, we have theories and parameters and numbers that we got to put in. It reminds me of doing like science class in school. We lost 20 people. What did I do? we were going strong. We were like 80, 90, and then it jumped down to 68. What did I say? Did I say clutch too much? Oh my God. I can't watch this guy. He just suddenly went, and I had to tune in somewhere else. What time is it? Oh, I know what happened. All right. I know what happened. Bop, 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 bop. What's going on? Oh, yeah, that guy's tweet sold for like pennies on the dollar. It was supposed to go for like 50 million, and it sold for like 200 bucks. Ha! All right, upload. I love my 2i2. Yeah, I don't know the generations, but mine's slightly older. It was the new generation when I bought it, but it's a nice little thing. I don't really use it to its best. I don't do the most out of that. The VSTs are what makes my audio palatable. Did this upload? I guess it didn't need to compile much. Why are these numbers still inflated? Oh, because they need to be gas 8, brake 8. Whoops. I actually am not overwriting the variables. That's nice. For once I'm not killing my variables. It's because the Teensy has so much overhead that you can just do whatever you want. Like, honestly, like the Teensy 3.2 can do your homework for you. It is so good. There's so much program memory and space and speed in the 3.2 compared to an Atmega 328 compared to an ATtiny85. Nowadays, though, I think the chips that they're running in these things are in like the modern Arduinos that we have are probably just as good. But back in the day, this thing was this thing was a powerhouse. That already uploaded. Boop. 0, 0, 255. Which one did we do backwards? Which one's the first one? The gas is backwards? Back that gas up. Hold on. Why is that one reversed from the other ones? Weird. So if I just do 255 to 0, it's a silly way to do it. It's too bad I can't just like, I mean, I could put in some programming stuff so that all this stuff could be adjusted at the top of the code, but we're just raw dogging it like this. All right, upload. We're down here. We're down here in lines 400, tweaking stuff. That's unheard of. We should not. This is bad programming parlance. We should be up above. We should be up above it. Not down in it. Oh well. But now they're all 255. Ha ha! I've won. I'm the wiener. Thank you guys for the follows. We got introverted follow mode on here, so I'm not announcing anything like that. You know, I'm not gonna put the brakes on the whole stream to go, oh my God, thank you so much for following. I got work to do. Subs, however, I will definitely fawn over. That's my guarantee. All right, so gas pedal. 255 to 2. Dun, dun, dun. What if I really press on it? 255 to 2. That's an okay range. We could still tweak that, though. Brakes. 255 down to... Oh, my God. That is a lot of force. Jesus Christ. As long as it consistently returns to 255... Yeah, down to 20, so our range is even more limited. God, I feel like such a fat ass over here, just sitting back, streaming. That one actually goes to 0, and it immediately changes. Good. The clutch actually is the one that has all the good range to it. So the brakes, minus 30, gas minus 2. I could adjust it here. I should probably adjust it up here. So what are we? We're 30 from the bottom. I'm not sure if we're limiting it 30 from the bottom on this. 5,000. We only saw it barely go to 40. Man, where do I do that? I guess I do it here. But if I take it to like 49... 49900. Or I subtract 30 from it in here so that I can actually get to the bottom of the range. The gas was -2. It's really the constraint that needs to be expanded, right? Yeah, let me unconstrain this, actually. I mean, we need wiggle room in the numbers anyway. How does that work? Wait a minute, I gotta think about this real quick. I mean, I could just, like, expand the constraints out, and if we're running in... Well, we're not running into the constraints, because we've expanded it on that scale. But I can't get enough force into the gas pedal to get it all the way down to 50,000. I'm off by 30, which could be 3,000. But if I scale it from a larger number, because it was like 52, wasn't it? It wasn't quite 5,000. Let's put a 52 in there. Well, I'll leave that one at 5,000. We'll just try it. Let's just try it and just see what happens. All right, let's see here. There's it wrapping around. The constraint should have prevented that. Suddenly it thinks I'm not pressing the brakes when I'm actually giving it quite a lot. It should be going to like a floor. I guess that 255 variable is wrapping around. We've allowed it to go too far in a few places. That's what happens when the scaling and stuff doesn't match. So this 52, it was mapped on a range that can go out of 0 to 255. So if I constrain it here to 52, that'll limit the lower travel, and it'll keep us from wrapping around. Beep, boop, bop. Here we go. Oh, it's already done. Jeez. It's so fast. All right, so brake pedal. Blah. There we go. All right, so I got the full range there, and it's a little bit more than just leaning on the pedal. And if I put way too much force into it, it'll stay at the floor function. The clutch goes all the way down to 0. The gas goes all the way down to 3. So we need to tweak it by 3. 3 numbers. Is that up or down? Well, we're not reaching the end of this. So 51. 5-1, and then 5-1 on the lower end. So where the gas pedal travels all the way from... Oh no, is it low number to... It's the opposite way, isn't it? Control Z, Control Z. 829. And clutch, you're perfect, and I love you. Thank you for just being you. Upload. Bum, bum, bum. God, now I got 1987 Trent Reznor stuck in my head. 86. Bum, 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 I was up above it. All the way down to 0. All the way down to 0. All the way down to 3. God damn it. All the way down to 3. You son of a bitch. It didn't do anything. How come that didn't do a damn thing? So when we map it, we're mapping it the opposite direction. So it's currently at 148. It goes down to, 826, 543. Yeah. I was just figuring it out. Our numbers are, the number line, the sacred number line is being violated.
What is that badge? TwitchCon 2018. Oh, that's cool. I never did the cons. And now everybody's full of putrid snot. So I don't know if I should. One of the complaints that I would always hear from the content creators from coming back from a con is that they would invariably get a cold afterwards. They'd be shaking hands and, you know, rubbing elbows with the people and getting their mouths sneezed in, I guess, and come back with a disease. So I'm like, you know, I don't really need to do that. All right, so back to the serial monitor. It would be fun to go to one, though. It would be fun to go to one. I get to go to the partner pavilion or whatever the fuck they have for partners there. But apparently there's another level of partner that's like the actual popular kids. There might be even two, but there's like, apparently there's places that are roped off for like the really popular people. So that's not me. I need clout. I just need clout, chat. Why are you denying me the clout that I deserve? It's still going down to 2. What the fuck? It still goes down to 2. Why didn't this work? It's going down to 2. It should be going down to 0. Never got sick. I just always lost my voice. Yeah. Places for affiliates and partners. But I thought there was like an even more special place for super special partners. I'm just going to make it 820 and see what happens. 820, upload. Con crud. Ugh. I got con lung. It's like Star Trek with lungworm. I was like, oh, lungworm. Ugh. Why? Why do you do this to me? I like making it wavy. Wavy line. It still won't go below 2. Let's look at the numbers again. Yeah, we might just be putting it out of spec, but if I just put the regular gas number in here, we'll just take a look at that real quick. Now, obviously, I could put stuff into this program where I could request that it gives me this stuff instead of having to constantly reprogram it, but whatever. That is as definitive as we can get. 148, 823. 148, 823. And yet, why are you going down versus up? Just the way it is. It doesn't matter what direction you go in as long as you program stuff correctly. And I can reverse the direction once we're done here. It goes down to 2. What a bastard. Yeah, I think it has to do with the range. Let's take it to 820. It'll give us a little bit more of a ceiling. Wait, if I do both of them, then it'll probably run into the same problem, right? Yeah, each division is 2. Let's do 823 here and 820 on the range. 820 on the constraint range, that is. Welcome to the constraint range. 3. What the fuck? 3. We got 3. We got 3. We got 3. What's the secret here? Is it the other way around? Do we want this one to go 820 and this one to do 823? Try that. I'm just throwing numbers at it and seeing what sticks. There's not much science. I mean, I could actually work out the equations and figure it out, but I'm too dumb. 1. I think each division of this thing is 2. No, it's a little less than that. But it's not exactly 1-to-1, you know? It doesn't scale quite right. So yeah, if I take it to 819, it'll probably be okay. Beep, boop, beep, bop. Or if I flip these around, it'll probably be a little bit better. It'll go 0 to 255. We want the gas to be accurate. I want it to have that full range of 0 to 255. Which it does now.
So now, I mean, if I want to, I could just flip these. Probably better if I had like a single variable to do this, but limiting them to 255 sucks. I really wish we had 1024 to deal with here, but 1023 to deal with here, but we don't, because of these, whatever they are, the potentiometers. See, the whole point of this is to program a digital potentiometer, and it only does 0 to 255. So that's just what we got. We got all this beautiful data running around. Oh no, we ran into the same problem. So this can probably be put up to 823, but then these need to be, what was it? These need to be lower. So 64,600. This one's going to have to move an order of magnitude, whereas this one, that was 823 minus 3. So 863 on that one. We'll figure out the big one in a minute. When we flip it over, I guess the way that numbers are scaling in doesn't give me that floor. Oh, we almost got it. Oh wait, no, that's the wrong direction. This is going to become a 2. No. So like when it squeezes these numbers into the map, we're basically taking like a bunch of numbers and making that one value. So 863 versus 864, nothing has significantly changed. But 866, 863, 860 probably is enough of a swing to get us a 0, and we'll make sure that we get all the way up to 255. Might make a little bit of a dead zone, but there's that. And then if we press the clutch all the way in, oh, hold on, I'm moving everything. 255, all right, perfect. 0 to 255 on that, and then the brakes, I mean, there's 255, but it goes down to 2. So we do the same thing with that. What up, FK Productions? How you doing? What was I talking about a little while ago? I mentioned to you. I think it was how big your butt is. No, there was something legitimate that I was talking about. So we need to move this map just a little bit so that it becomes 0. If I do 600, getting rid of 20 values, it is pretty big. That should get us hopefully close to 0. No, I forget what it was. It was something legit. I was talking about, damn it, I don't remember. Okay, so 64,600 still gives us the number 1. So we need to remove more. So let's go 550. Or let's do 580. Because we're removing like 20 at a time. Let's see what that does. And that should probably finish the ranging that we're doing here. This system feels quite... No, 80 is not good. 550. We're removing a lot of numbers. I guess we were on the line for that last one. Access to the new building at Navy Yard, May 1st. I got a buddy who's near there. Oh, there we go. Now we're at 0. Yeah, the Navy Yard is like, man, they're turning that whole area around, aren't they? Is that beyond the where all those apartments are? Because there was like almost just blank space beyond my buddy's place. It was like warehouse space or something. But they've also got that nice building there. Oh yeah, you guys can't see the numbers. So we're looking at the clutch pedal, 0 to 255. Gas pedal, 0 to 255. The gas pedal sensor is beautiful. It's like a beautifully engineered thing. Brakes, I have to actually like lean on to get all the way up to 255, but that is a significant amount of braking force. So that feels like actually driving a car. It feels like it's a little much, but I can always scale it in software. Yeah, because I'm actually like, it's actually like affecting my chair. Yeah, I'm pretty happy with this. I can just tap the brakes. Now, I typically will rest my foot on the brake a little bit. That's a pretty significant swing. Now, let's look at it in a chart. Comcast. Oh, God, you're having... I have a buddy who has a lot of problems with Verizon. Actually, this groovy something. That's what I'm talking about. Port, blah, 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 blah. Serial plotter. Look at this plot of values. My God. Absolutely amazing. The type of data that we're getting coming back. I actually love this kind of stuff, by the way. This is I love this. I love getting data from an Arduino and scaling the serial plots and doing all that stuff. Clutch. No clutch. Clutch. No clutch. Clutch. No clutch. Brief clutch. Little clutch. Half clutch. Half of the clutch. Actually tough to maintain. This is probably not as linear as it could be because the Hall effect sensor kind of has like a switch over. So a Hall effect sensor, God, I feel so lazy sitting back in my chair, just like hanging out. A Hall effect sensor, when you've got two magnets that are close to one another, they create what's called a Hall in between them. So all of those magnetic ley lines, if you will, sort of meet up with one another, and then you have this smooth transition from north to south, as long as your magnets are the right distance from one another. So what's going on here is I have two magnets that are stuck to a washer that are then ultraviolet glued in place, but they're hanging out around a sensor. And so as the clutch pedal moves in and out, it's moving closer to the North Pole or the South Pole of the magnet. But there's a little bit of like a crossover from one to the other. The Hall effect sensor board is from a 300 Arduino sensors board. It was like a kit that I bought from China like a million years ago. So it's good to finally use part of this thing in this setup. But, big bucks. But, as the Hall effect sensor goes from seeing one magnet to seeing the other, there's like an adjustment on it. And you can adjust it to be nice and smooth over that transition. I think we have it pretty smooth though, because that initial, wow. How did I get full? Oh, because it's scaling. That's right. Every now and then I have to remind it of the full scale. The Arduino plotter scales. So actually what I can do is send it two values, two extra values, and that'll be 0 and 255. And what that'll do is that'll just jog the Arduino plotter to be stable. There are so many BODs running around here that I don't even know which one to tell you. The LIN-bus protocol is running. Ooh, sorry, hold on, hiccups. I got this thing with diabetes, chat. I got this thing with my disability, where my stomach doesn't like to drain. It doesn't like to be, it can't really operate that lower valve as well as it should. Very mild case of it. But what happens is when I'm streaming like this, I'm talking with you guys, I'm moving my diaphragm, and then all of a sudden my stomach decides, hey buddy, guess what? We're gonna drain. And the valve is like, no, we're not. And then so my stomach just goes, and then I'm like burping hot fire. It's just one of those things that I gotta live with. The BOD on the Teensy, right now the serial is coming back at this folder. Wait a minute. It's coming back at, I don't know. Here. We are at, God damn it. The Teensy works in mysterious ways. I don't know what baud this thing is at. It doesn't tell me anywhere on the Teensy serial monitor. Usually it does. 11 to 5200, 96. Well, actually, we configure serial at the top of the code here. Yoink. All the way up to the top. 11 5200. There we go. That's the only reference to the baud that I have right now. With the older versions of Arduino, you have to like configure the baud in the serial monitor. If you get it wrong, you get a bunch of weird characters. Same thing that's happening with the LIN-bus, where it gives a timing signature instead of being told that it's at a certain baud, which is something that you find a lot in radio communications, where you have one radio wire, one frequency coming back into your radio device. And so what you do is you send it a little timing sync so that everything can get into phase and sync with each other. Yeah, those are our calibration numbers, and then we have the gas, clutch, and brake. So let's go to the chart, the serial plotter, and now we can plot our serial. and it'll stay in bounds. It won't fly all over the place. Ah, now I can sit down again, and I can fully take in all of the wonderful complexity of the system that I put together. I'm happy about this, chat. I think we got a good system going here. I mean, the gas pedal is like as perfect as I think it could get. This thing is like amazing. It's got a capacitive twist sensor in it, which is basically just a circuit board, what is mounted near another circuit board, and everything's just a bunch of like antenna style structures that just twist against each other. It's basically what the iPod used in order to, nobody knows what an iPod is. Like, all the Zoomers in chat are like, what the fuck is an iPod? It's what they used on those touch contact iPod sensors. Ooh, I got all this control. Can I draw a penis? Oh, I'm not patient enough. Hold on. How do you do a circle? Oh, it's a little tilty. I'm not patient enough. Hold on. We can do better than that. I can draw a better penis, chat, I promise. Oh, no. All right, so sustained injuries aside, it is possible. How linear is the clutch? It's pretty linear, actually. Yeah, it feels like it's like a little softer than a real clutch, because we didn't quite get the spring right. McMaster car only had one spring with all the specifications, and it happened to be almost exactly what we needed. But we do get data values throughout the entirety of the travel. Oh, maybe not. No, we do. This is me tapping it just barely up against the backstop. And then when we go all the way down, perfect. There's a little bounce at the bottom there, but that's all the springs fighting each other. Now, the brake pedal is insane, and I might have to change it a little bit, but in order to get full brakes, I'm like really putting a little bit of muscle into it, and it probably should have less range than that, but it's on a load cell, so it's super sensitive. Super duper. I had in a previous life, I had the Cytec, I think it's Cytec, X65F. I still have the throttle and the joystick still. I want to put that throttle on my dual joystick setup because the throttle is amazing. But the Cytec X65F's claim to fame is that it is a load cell. And that load cell makes it so that it's like the F16 flight stick. From what I hear, and I haven't confirmed this, the F-16 flight stick, you have 1 inch of travel in every direction, and after that, it's force sensitive. So it's not Star Wars. It's actually sensitive to the amount of weight that you put into the control. So with the Cytec X65F, I had absolutely no idea if I was reaching the maximum control authority, right? Like, and this pedal does this too. I don't know where the end of the travel is because I'm putting so much force into it. I can't even feel it hitting the backstop, which is bad. So I will not know if I am at maximum braking force. I'll probably have to lighten it up a little bit because I don't want to have to put my full body weight in this thing every time. Probably have to put it like here. But that's for later adjustments. But with the X65F, what you would end up doing is getting like a white knuckle grip on the joystick and trying to move it around. And then I'd stop playing the game and I'd be like, man, my arm is tired. Or I'd slam the thing down on the desk trying to turn it a lot harder. Use the force. Yeah, all those jokes write themselves. I can't get maximum clutch and brake at the same time without like contorting my body a little bit. They might be a little far away. But then again, clutch we can make operate in a different range. Depending on how the game handles it too, because I don't think you need maximum braking is for like when you're racing the car around or an emergency stop. It should be okay with like a moderate amount somewhere around here. Why is that moving with? Oh, because I'm hitting the gas pedal at the same time. I was like, why are two of these values moving like that? Heel toe, heel toe. Look at the power of heel toe. Yeah, pretty cool. Put the clutch in. Heel toe. Granny shift. There we go. Double clutch. That was the brake, or the gas. Double clutch. Okay. Actually, double clutching, isn't it when you, like, put it out of gear, get the synchros going, and then put it in gear? I think that's double clutching. Not sure. Well, this is good data. This is good data from the pedals. I'm happy with the pedals. We know that the shifter works because we rearranged the packet around. We know that it gets into the controller. Everything is pretty much ready to go, save for the fact that I cannot program enough buttons on this thing to work. So the values that are going in through this thing, getting scaled to 0 to 255, those go directly to digital potentiometers that will fool the Granite Devices controller into thinking that everything is plugged in. In addition to that, I have 8, I believe, more ports that I can control. Okay, how many ports do we have on this thing? All right, so let's get rid of the serial printout. Or we could just keep it. It doesn't really matter, actually. I'll just keep it the way it is. I don't care. We'll keep those, because it's whatever. This thing is typically not connected to serial, so none of this stuff will actually do anything. Whoa, my bit rate's all over the place today. Did I drop any packets? No. What game is this for? My Summer Car, specifically, which is not really the kind of game that you build an entire sim setup for, which is why this is so awesome. This is a Granite Devices SimuCube that we are making speak digital language because the steering wheel that I bought, thinking that I would be playing all kinds of different racing games. Turns out My Summer Car is the only game you need. But anyway, I bought a Mercedes S-Class steering wheel. This is like 2015 that I bought this thing. And so it sat around for a couple years until I could figure out what I was doing with the rest of the sim setup, and before I had the stream really going. With the stream, I'm able to concentrate and funnel money into a single project at a single time and get cool stuff like all this crap, like all this garbage that's sitting around here. So the Granite Devices SimuCube is part of the Granite Devices like family of universal motor controllers. Does it look like it? What indicates this is the, like, why would you think this is BMW? That's completely stupid. Anyway, Granite Devices SimuCube. Granite Devices has this wonderful setup where you can use almost any three-phase motor or stepper, four-wire stepper, whatever, with their controller, their big industrial controller. It can be tuned. It can be tuned to a variety of different motors, and then you can use easily commercially available. I'll whoosh myself. No, that was a joke. I was being stupid. It's just a BMW airbag cover, just because it makes the wheel look less like there's a giant gaping hole in the middle of it. This is from my old car. I actually bought a different steering wheel, and then the M wheel I kept when I sold the car. So, and the M wheel's on my current 1999 528xi. It's a couch on wheels. But yeah, so I was left with an extra airbag sitting around because I bought an entire BMW wheel. And so the airbag I took apart, took the detonators out of it because I'm a little nervous about having an airbag in such a dry room as this. And so the detonators are sitting in an ammo can that's actually, it's like right up there. I could kick it. I could kick it right now. No, I can't get to it. All right, anyway. It's the airbag's detonators are in that ammo can, and then I just had this cover to shove in here with a bunch of the foam that I used on my walls. So there's a certain degree of jank to this entire system. But anyway, so this wheel was sort of the claim to fame of the entire project, right? I had this cool leather wheel that had nice grippies on them, and it has the paddles in the back in case I want to feel like I have an expensive car. This steering wheel, though, in order to get the values of the buttons, you have a couple different strategies with sim setups. You can either find a wireless wheel module, which, you know, is a Granite Devices thing, where each button goes to a pin of this wireless wheel module, or you can, what are the other strategies? I don't know. You can run a shit ton of wires all the way back. You can have a little curly Q plug that you plug in. You can have like a what's called a clock spring on the wheel. But the problem is when this thing is off, it is a 20-pound disaster to move around. And so having the wheel able to go 360 degrees is rather important. Now, in order to do that kind of thing with like a wireless wheel, I could have hooked these buttons up to the wireless wheel board, which is another $100, and then had it wirelessly transmit back. And so I'd have to charge my wheel, but more importantly, I would need to get one button per high or low signal, and that's not how the wheel is originally designed. It has banks, it has weird banks that need to be multiplexed, and I don't think I have the ability to do that in the wireless wheel module. It would be nice though if I could just take it over, because then I could control the backlighting. So instead, what we did is we hooked the wheel up to an Arduino. Obviously, everything always finds its way back to the Arduino. We hooked it up to an Arduino, and we looked at what the automotive specifications are for the language that this thing is speaking on the bus. And it turns out that it uses a chip that referenced the LIN, I guess just the LIN bus, Local Interconnect Network. It's an automotive standard from a consortium of a couple different car companies that decided that they would have a cheaper thing than CAN for all of the super low priority things, like shifting in a Mercedes is super low priority apparently, and you know, your radio buttons and stuff like that. You have all kinds of different, bus types and signals and all kinds of different buttons and things, but a lot of them can be LIN bus, I guess is what was I trying to say? I lost sight of that sentence in the middle of it. Anyway, LIN bus it's a very specific protocol, and what we were able to do was use the Arduino in order to do what's called bit banging. Bit banging is when you very specifically control the timing of the microcontroller and the ones and the zeros coming out of it, instead of relying on like a serial stack or interrupts or things like that, right? Because we didn't know how far we were going to implement this. So what we did, there's only a limited number of addresses on the LIN bus. There's only like a handful. The chart of values is like a page and a half. You can get through that in a split second with a microcontroller. So what we ended up doing, and this is even before we knew that there was only that limited number. I was actually brute forcing this by counting up a variable. And what that was doing is that was sending legitimate addresses out, but it was also sending addresses that had bad parity bits at the end. The parity bits are somewhat of a checksum for the rest of the address, and that's why they're so limited. You have six binary numbers, 6 bytes that are the address, and then you have parity bits after them. What's up, Jem Chalway Duporziu? Arduino and NRF whatever module. No, we're not using anything like that. So we brute forced it, and we found that the steering wheel replied to one of the addresses. And so in that vein, I decided to make all of my accessories into LIN bus devices. So now we have the shifter, and that's communicating over the LIN bus. I got the pedals, and those are communicating analog over the LIN bus. And I got the steering wheel that's also communicating over the LIN bus. In the future, I would like to take the lighting module that I have here and actually make this communicate over the LIN bus, but we're not going to do that yet. What we now need to do, because I've got all this stuff hooked up and calibrated, everything works, everything communicates. We've got signals running around here, the likes of which you've never seen before. We need, we're not doing the airbag. The airbag is set up on a separate system. It's actually a safety CAN bus. There are different buses all around. Did you hear about LIN bus 2.3? I thought they were up to like 3 or 4. I don't know what 2.3 can do. But this version, I think we're like LIN bus 2-ish. They were barely even that. I mean, the addresses that I chose were wrong. But the different buses that you have running around the car, aside from LIN bus, you have different types of CAN bus. There's high speed and low speed. Oh, you're just messing. I don't know what number we're up to. I don't know anything. High speed and low speed CAN buses, as well as high priority, low priority. It's a mess. Cars are a mess. And all those different buses sometimes have a module that goes between them. And so theoretically, if you are a research scientist who knows exactly the chips and the memory structures, you could reprogram one of the modules that acts as a bridge between buses and do something like activate the anti-lock brakes from the tire pressure monitor system. Like there have been a couple papers about that recently. And the thing is, cars are a totem pole of technologies dating back to the 1950s. So it gets to be a mess. It gets messy. But again, you need to know, you need to have intimate knowledge of all the hardware involved in something like that. All right, so our system works. The LIN bus is carrying signals around. We're getting all of our values in. We have everything pumping around here. But we have a number of buttons that we cannot actually control. How many buttons do we have in the actual CosmoQuest? Man, my brain is like stumbling through this stream today, man. CosmoQuest pinout from Granite Devices, all the way down here. I got these X12 and X11s that I can use. Yeah, the buses fit in the cars, believe it or not. X12 and X11. Ethernet bus? I don't know. They don't want to have all that extra copper. Everything should be optical. I know BMW has like an entertainment like optical loop that they use, which is wild, but everything should be optical. Optical and power. Those are the only things that I should have to plug in. So, we're not worried about Hall. We're X12 upper and lower, right? 7, 14. What the hell are these? Oh, those are the analogs. 15. We have 15 available buttons overall in this entire thing. That's lame. Lame as hell. We have 15 buttons that we can possibly use. And there's a couple ADC inputs too, but the other ADC that we would use would be for the e-brake, but I haven't implemented that yet. 15 buttons, huh? 15 buttons, little man. Put that shit in my hand. If you don't got the dough, yo me oh me oh. Oh wee oh wee oh. Yeah, so X12 upper and lower, they just expect it to be switched to ground. We put a port expander on that. You can't multiplex these. So these go into the Granite Devices controller, and they're directly implemented as buttons. The only other way to get more buttons into the system, from what I understand, is to get the wireless wheel module, which has 28 buttons on it. Now, if I just used that wireless wheel module and just clicked 28 buttons, we would have enough, because we got 12, 13, 14, 15, plus 8. 16, 17, 18, 19, 21, 23. So I could actually make this work if I just power the wireless wheel module and put it inside the enclosure. But that means that if I expand it, then we'll have to do all the serial sniffing. So let's plug in the wireless wheel module, and let's just look at the serial packets that are running around. I'm concerned about the complexity of running an entire serial array on this thing and making it seem like a legitimate device and stuff. It should be doable. It should be doable. But we have to like transmit like the MAC address and a bunch of other stuff. And I don't know if there's going to be like a "Are you still there?" kind of thing. Scan all ranges. Scan them all. Basically what we need to do is we need to look at this thing on startup and figure out what those packets are, and then, I don't know, characterize the packet. One thing that we can do right now during this Thursday stream. By the way, I'm not around tomorrow. I'm babysitting a dog for a friend of mine, my buddy St. Wiggly in chat. He has a golden retriever puppy, and she is adorable. She's kind of like a lanky golden retriever. I'm gonna be taking care of her over the weekend and paying my state taxes, which is always fun. State taxes. Hope she pees on your shoes. Me too. Yeah, but so I'm gonna be taking care of this puppy and doing my taxes. So I'm not gonna do a Friday stream. Saturday, I'm probably, unless I do my taxes like in 5 minutes, Saturday probably won't happen. But if it does, we'll just like hang out with the puppy. We'll just hang out with the puppy. It'll be fun. But yeah, her name is Jelly. She's adorable. There will at least be a picture in the Discord so that you guys can be like, oh, that's a puppy, and then everybody will move on. Okay, so And I won't know until August. No, 1 month from now, whether or not I'm getting a corgi puppy. I might be, but I won't know. We're about to start, hey. Well, now we're definitely not going to sniff anything. No, we're about to start sniffing. We're about to, everybody get your noses ready. And then let's get ready to start sniffing. I'm going to start sniffing here. Tutter calls corgis loaf butts. It's true. Unfortunately, this corgi that I would be getting, while it is what it's a fluffy corgi, which breeders hate fluffy corgis, but I hate breeders, so that's great. Anyway, it's a fluffy corgi, but it's gonna naturally not have a tail, which is, I wanted to have a tail. I wanted a mutant corgi. The other option is to get a Valhund, just to go with my brother getting a Finnish Spitz. All right, so we got our 2 buttons on here, right? And these are the shifting paddles, right? This module requires you to have the shifting paddles hooked up because that's also how you tell the Bluetooth to go into discovery. So you'd hold down the pedals, or I think you just hold down the pedals. You hold down the pedals for a certain amount of time to disconnect. You do it to connect, et cetera, et cetera, et cetera. So, and supposedly this thing is so low energy that if you put a normal sized battery on it, it'll last for like a year in the wheel without being recharged. I'm not too certain about that. We didn't check current on this thing, but you know. All right, so we need to hook this up. We need to hook up the pedals to this thing. Get a cat. No. I'm allergic to cats, man. I like kitties. They're very cute, and they're very low maintenance, and they're sometimes hilarious, but unfortunately, I am very allergic to cats. Not like deathly allergic, but like uncomfortable allergic to cats. All right, how are we hooking this thing up? How do we hook up this piece? So I've got 2 buttons here, and I'll just loop a wire up and around. And I think 2 connections to ground. 2 connections to ground. Okay, so let me move this up a little bit. I'll plug it back in when I get it all hooked up. So ground needs to go out to these, and then we get the 2 buttons back, and we hook it up to the other 2 buttons of that thing. And hopefully the pushing of the buttons is enough data for us to actually get something out of this. But I'm not certain about that. I have my doubts. I have my doubts, but I'll keep them to myself. You always have Chad. Boy. Take that sentimental garbage out of here. We got work to do. Ground. These aren't broken in. Hold on. I need to actually take a pin tool and break in all of the frickin' things on this, because they're too grippy. Too grippy. So I'm going to poke them out. Little grippy things. Corgi butts are hilarious. I will take pictures. That's got something plugged into it, so I guess that doesn't work. Okay, whatever. Just trying to keep these from being annoying. The clips are a little too harsh inside of this thing. What happens when you buy stuff new instead of just recovering it from somewhere? Yeah, gotta break them in. All right, that should be good. Well, I'll keep going. Just try to get this lower row here, because I am gonna need all these pins. This is a very small breadboard, perf board, whatever. I guess we did move the entire shifter circuit off of the board that it was on. So I guess I could transfer this back over to the slightly larger one, but I don't know how long we're going to be working with this stuff. And I can keep it on this one semi-permanently. Yeah, the new breadboard and like plugging in wires and headers and stuff, it like explodes if it's not broken in properly. Or not broken in. I don't know if there's a proper way to do it. I don't have access to... Oh, yeah, I do. I actually do have access to that. So I can jump that over one row. Oh, God. Yeah. Jeez. You calm down. Loosen up. Taking everything so seriously. Perf board, breadboard. I'm going to try to do my taxes tomorrow and see if I can get through them. I don't know how stringent Philly tax is. Not Philly, but Pennsylvania. PA state taxes, clean coal. I don't know how... It should only take me a couple hours, but man, it's really weird, the situation that I'm in, because I didn't pay enough, or I didn't get paid enough to do federal. So I'm just doing state. I don't make a lot of money, chat. You guys are pretty cool. You guys get me a lot of money. But it's not like I can itemize. I've tried in the past, and it's taken me like days to do the taxes, get all that itemization information together, and then the tax software is like, yeah, you should just take the standard. And I'm like, oh. Oh, okay. I guess I'll do that. I guess I'll just do that. I guess I wasted 6 hours of my life over the past 2 weeks trying to get you all the information that you could ever want about my entire life. Slightly shorter. Slightly shorter. Where is it? Where is it? That's a 1 skip. I need a 2 skip. That looks like a 2 skip. Yeah, man. I envy the days when I used to just go to work and get a paycheck and they would take taxes out of that. Because then it was just like, ah, shit, did I just lose the... No, I found it. You could do your taxes in 5 minutes. I didn't do that back then. I was adding up all my medical expenses and stuff to try to figure out whether or not I counted for any kind of like weird deductions. Nope. Should only be so lucky as to be able to actually functionally do stuff. All right, what's the pinout on this piece? Well, I need to figure out which ones and plug it in. All that work. Technically, I have a business, so I don't know if I need to do any business stuff with them. But where in the hell? Where's a pinout? Hold on. Shouldn't it have all the info? Oh, there we go. That's what I'm looking for. Really? Paddle 2, paddle 1. So it's these two over here. Those are the two that are like cross from one another. No, I haven't done LLC. I'm thinking about what I should do though, because these are different length buttons. How did I possibly build this with 2 different length buttons? Oh, that's gonna bug me forever now. Oh, that's just gonna continually piss me off. Wow, how did I 2 different buttons? What was I thinking? Oh my God, chat, I can't do it anymore. I just can't. 2 different buttons, different lengths, but like not like significantly, so that it's like kind of a special thing and you think it's purposeful. They're just different enough to just be annoying. This is breaking the wire. Samir, we're breaking the wire. Pay attention, Sammy. Poor Sammy. Never did pay attention. I feel like past bother is a sadist. No, just criminally negligent. Criminally negligent. You see how much easier that is now? All right, and then the blue and the white and purple. What's the one on the... Pin 2 is LED. Did I ever hook up something to that? Oh yeah, we actually soldered the LED on the board. This one is LED, and then these 2 are the paddles, so purple and white. So that would be the last 2 pins, and I just need to get 2, probably gray, this length, so that I can hook them up. We populated this board like immediately after. Sorry, when I had to move this thing over here for the shifter, we put it all on this board, and I never hooked it up. So never hooked it up. I wonder if I can do this with all blues. Let's do this with these. They don't need to be that. No, they do need to be that long. Okay, so slightly longer. Where is the gray wire? There it is. Gray wire. Put that one in here. Move it over to here. Yeah, the crimes that I've committed against myself, my past and future and present self, are varied and interesting. Okay, so all this needs to do is to activate the serial signal. So we will run the power supply all the way over to this, because I need the whole system to be on for this. We'll run the power supply all the way over to this. I'll need to find a ground on the Granite Devices controller so that we can have a reference point for the scope. And then this will just be our own little device over here. I mean, I could hook up a battery to it and actually run it like it is, you know, the system that it's meant to be. But I think it'll be okay. We'll just do power supply on this thing. So let's hook that up, and then we can start probing around. I really hope that this serial signal is going to be just super rudimentary and easy to read. Because if we can put it into an Arduino, then I can record and characterize large swaths of the serial signal. Otherwise, I don't know. Otherwise, we're in for a bit of complexity here. So here, let's back it up. Take a look at the whole setup. I know, I'm going to be very disappointed very quickly. All right, we can unplug the LIN bus master. The bus master. Bus. LIN bus master unplugged. And then we come over here. I guess we're going to have to hook up to USB. So I've got that ready to go. Let's plug in over here. We can get rid of the 15-volt hookup. I got the hookup. All right, get rid of the 15-volt hookup. Turn that off. It's too bad these banana plugs didn't work out. I thought I could plug them directly into the power supply. So now we're going to actually use the 48-volt power supply. That goes over there. This gets coiled. What are you guys? Is my giant face in the way? No, okay. I don't mean to get all these weird, intimate camera angles, but I'm running out of space. There's a constant struggle around here. Streamer, why do you exist in 3 dimensions? You're getting in the way. I guess I'll plug these back in for now. Well, I need them plugged into the analogs, I guess, too. I don't know which one of these is the analog. Plug it all back in. Probably should have labeled these a little better. That's okay. All right, so those are all our button hookups as well as the analogs. And then this one comes around here like that, plugs in over here. This is pretty compact. I wonder if I should have put it in like a rack mount thing. Maybe like a 1U enclosure. 1U would be too much for this though. It'd need a different power supply too. USB cable out of the way. These LIN bus cables are not useful at the moment. Goes over there. The wireless module. I don't know what signals are running on this thing. I think we can look up what's connected where. We have a pinout of the header, which we can find. What header is that? It's the front one, and it's labeled. It's not labeled. It's right next to all the LEDs. J22. Let's look up J22 and see what it's doing. Because we know the signal names. Camera security. Rating with party of 3. How you guys doing? Welcome to the show. Often wonder this kind of stream could make use of a super stabilized head-mounted camera. No, because I'm looking at stuff that you guys shouldn't see. My desk is full of address information, and I just don't want to dox myself. It's like it's all dildos and addresses on my main desk, so you guys don't get to see that unless I prep it ahead of time. So let's see here. We're looking for. We got the SimuCube pinout, so. And White Claw. No, I haven't had White Claw in a while. That was my pandemic coping mechanism, was buying, because in Pennsylvania, clean coal. Out here in Pennsylvania country, we have beer distributors because our laws are
weird. They're really weird. Like, my local supermarket had to install a bar in order to carry alcohol. There's like old dudes getting drunk at Acme. Like, what the fuck? Like, what is that? Why can't they just sell alcohol? And then I moved to Virginia, and there was like bottles of wine and shit at CVS. There were like bottles of wine at CVS, and I'm like, I'm pretty sure all the stuff behind that counter is to undo whatever this shit does to you, right? Yeah, I hate the Pennsylvania, like, ordering. I can't get fancy whiskeys online. I have to like drive to New Jersey and shit to do it. It's so bad. Friend visited out in Westchester, and we ended up going to Delaware to get beer. Yeah, that was part of the pandemic strats too. Going to Delaware to get your beer. They allowed us to order online from the ABC stores for a little bit during the pandemic, but it's still the same selection and the prices too. A bottle of how do you say it? Laproig? I call it Laprohag because I've never heard of it pronounced. I've never heard it pronounced. Anyway, like a decent peaty Scotch, right? Or whatever, good stuff, right? Yeah, whatever. I don't know how to pronounce it. In an ABC store, $50-something. Online, $30. I'd be drinking a lot more of that stuff if I could actually buy it at a sensible price. Laproig or something. I don't know. Anyway, it sucks. But so what we have around here are beer distributors, and the beer distributor, because you buy liquor from the ABC store, which is a state-run store, and then you buy beer. It smells like an ashtray. I disagree. I have to respectfully, or maybe unrespectfully, disagree. But anyway, if hold on, this has to be visible at all times. There we go. I'm legally required to have dick butt on screen. The beer distributors are literally the distributor that sells to like bars and stuff like that. So you can actually get compressed CO2 from them, or you could buy pallets of stuff. And so what you end up doing is you end up buying like 2 cases at a time for a good price. I mean, the distributors are great, but you buy a lot of it at a time, and then you get the cardboard thing that organizes it. And so that cardboard thing that organizes it is a nice project tray. It's a nice cardboard tray that's like kind of, unfortunately branded. And so you guys have fingered me as somebody who drinks a lot of White Claw, whereas in reality, that's just the best way to get that stuff. And it's also no carbs. So fuck you, I have diabetes. You should all feel bad about that now. Yeah, but what I do is I go to the distributor and get a bunch of it at a time and then drink it, and it doesn't end up really doing much. You don't really feel like you're getting drunk, and then it's all gone, and you look at how much you spent on it and you cry. And those cries are pure seltzer tears. Okay, anyway, that's why I have a bunch of those trays. They're really convenient to put a project, like all the parts, all the miscellany from a project in, and then get it off of the desk so that you can work on something else. And when you want to go back to that project, grab the tray, put it back down. That's what I have in the shelves over behind the 3D printer. The other trays that I have are from Tired Hands, so maybe I should be buying Tired Hands from now on, but it's tough to get all the way out to Ardmore to just get a couple cases of beer. And it's also like $100 every time I go. So Tired Hands is beautiful, amazing stuff. It's a brewery around here called Tired Hands, and they make the milkshake. They were the ones that very much popularized the milkshake style IPAs. And think about a milkshake IPA. So everybody's running around beer like kids with guns. They just don't know what the fuck they're doing, and they're like, hops is really bitter. I like this. And so they're like, let me increase the amount of hops and let me put more hops in it. And let me add another hop schedule to it. And then I'll do a dry hopping. And then we'll actually put a hop in the beer while you drink it. And then I'm going to hold a hop in front of your nose and fucking punch you in the face with it. Isn't that great? It feels like you've just passed a pine cone through your digestive system. Isn't hops great? I love hops. These fuckers. Like, fuck. Just stop it. Stop it with the hops. We don't need more hops. Hops are great. you put it in balance with the other multi flavors of the beer, and that's really where it comes into fruition. But these fucking IPAs like lost sight of it, and it became a contest. What Tired Hands does is they have an aggressive hop schedule for the beer that they brew. There are hop additions every half an hour. But the interesting thing that happens during like a couple hour boil, I think it was like 5 minutes for it was a copycat recipe, so it wasn't exactly the recipe, but they add a lot of hops. And what happens when you add the hops again and again and again and again and again? It actually all balances out. It all balances out, and what you end up with is something that has, and they also do like lactate, or not lactate, whatever the, like lactose type stuff with it. They do some special stuff with the beers. It ends up being an extremely smooth, deep flavor profile from your beer. There's some really crazy stuff that they brew. So excessive hops is the equivalent to A1 on a great prime rib. That's true. Yeah, something that they do with that. I was looking at a copycat recipe a while back. I've forgotten everything because I drink. Alcohol's ravaged my brain. That's not true. I'm just forgetful about certain things. But yeah, so I don't know. There's a there's a copycat recipe, and it has a lot of information about like constantly hopping. But those beers are delicious. They taste nothing like what an IPA tastes like. They had an alt beer for a little while too that I really liked, but they don't have that anymore. I need to go back there and fill up my stock. And by the way, Tired Hands, I only mentioned it on stream because typically I'm not going to sit around and plug a local brewery, but they're internationally renowned. I know people across the country whose friends hoard Tired Hands. They apparently have a fridge full of them, and will have one like a month, right? And they just, there was a case of the beer went on a trading site for like $20,000 or something. It might have been $2,000, but yeah, they're very well known. What's up, Demi? I saw Demi in Sark last night, which was irresponsibly late for you to be up. I'm gonna be a bedtime cop for Demithil. Maybe he was waking up. Yeah, that might be what was happening. Serial display connector. Serial display connector, FTDI USB serial cable compatible. Wait, so that works with, wait. So that means I could plug in this? My little FTDI breakout board? You were going to bed? Man, that was late. That was late for me. I was talking to my cousin who owns a sour beer brewery. He uses lactobacillus bacteria to make lactic acid. Neat. Yeah, I guess that's what they do then, right? They put a bacteria in the beer and it makes it, I don't even know. Why did it get so dark out? What's going on over there? What the dog doing? Hold on, let me open up a forecast. I'm in a freaking basement. I don't know anything about anything. Look at me. I am not a surface dweller. Yeah, there's a storm's coming. We're about to get a bit of rain. Shouldn't be anything serious. By the way, my policy if the power goes out here, which it does often, supposedly we're getting a generator. I don't know when that's going to happen. But I have everything on battery backups. And so those battery backups will power the computers and the internet stuff for maybe 10 minutes, maybe. And I'll have time to shut everything down. But everything still needs to be shut down. And usually internet goes out like a minute or two after the power, because something in the neighborhood loses power as well. If the power goes out, stream stops. So that's my policy. We've had some bad luck with power around here. I'm still bleeding. What is this crap? I keep looking over and I have like a polyp on my arm. The fuck is this shit? Get off of me, you giant scab piece of crap. All right. Okay, so we're looking at that header and we're seeing things that we recognize. That's a James Cameron quote from a stupid interview. Someone get Bother off Twitch. He's bleeding all over the place. The horror. Swood. Swood? Swood.
what's interesting is that you can have a serial display connector. What is that like? If we look at a serial connector, like with the FTDI, USB serial cable compatible. I wonder what we'll see. I mean, if we, oh, man, okay, what's gonna piss me off? Listen, chat. What's gonna piss me off even more? I love this corner camera. I'm like, hey, chat. What's gonna really piss me off is if I can just plug in a serial cable to this thing and we'll discover everything we need to know without the $100 wireless wheel module. No, I think we'll still have to plug it in. All right, so I need to see which connector I'm supposed to plug this thing into. And then if there's just an FTDI connector in the corner, that's interesting. Whoa, what is all this? Oh, revisions, right. All right, we don't need that. I need the wheel module, and I need to know where to plug it in. Configuring the wireless button plate module is not possible without a programming device that they will not give me, the consumer. Man, I hate this. You didn't check that first? No. I think we won't be able to discover what that packet is going to be that tells it what wheel it is. I mean, we're just going to see ones and zeros initially, so it stands to reason that I would have to buy this in order to run everything else. Where does it plug in? Hello? Hello? Where do you... Yeah, just an arrow to the thing. All right, I can do that. There. Okay, so it's actually the, I guess, serial display header. Let's put this all the way over here, next to Big John. Next to FK Productions. Look at him. Beautiful. Yeah, I mean, that's what the arrow told me to do. So we're plugging into this one, which is the serial display connector. SerDisp. Pinout 1, Pinout 2, Pinout 3, Pinout 4, Pinout 5. Oh, so Pinout 4, ground, 3 volts, ground, TX, RX, 5 volts. Huh. All right. So we know what the pins are. I can plug in the module and then get clips onto ground and stuff like that. Or I could possibly like make an in-between. I think it'll be easier just to take a probe and just hit that TX and RX, and then we'll give it a ground. So let's set that up. Let's set that up. It's a nice TX and RX, right? We don't have to deal with whatever what do you call it? Crap. We call that crap. You don't have to deal with the SPI or like chip selects or something like that. Pinout 5 also has the same stuff on it. Wait a minute. Wait just 1 minute. PA 9 and 10 are on both headers. So we could use Pinout 5 in order to just plug into. Hey, how about that? How about that? Let's make a little connector then. We can make a little connector and it'll make our job that much easier. So I'll plug this thing in for now. What direction does it face? Huh, that's interesting that they have 2 serial outputs. Seems like maybe that aids them in some troubleshooting. I also am wondering about putting a screen on the thing. I think that would be kind of awesome to be able to do. Hardware flow. I have absolutely no idea. I don't know. I don't know. I just don't know. You? It's just like, hey, just plug it in. Oh, there we go. That's the direction. Okay, so with the thing over to the right. So this will plug in like this. I gotta like contort myself around in order to get to the plug. Just like that. And then I can plug, I guess I'll just use square headers. The square headers that I made specifically for this sort of thing. Yeah, that's what we'll do. You guys can't stop me. You can try. You can't stop me. Actually, you can't try, can you? Whatever. I could use one of these. That one seems a little unwieldy, but I think it'll help. I think it'll help. Hey! I didn't let you do that. Yeah, this will be nice and long. That way we can actually get to it. You won't stop me. Pathetic. Ground TX and RX. I guess I'll just deface this wire, and then we'll plug these three into that. Okay, so what's the separation? I can't get my hand in there. That's the only problem. Look where my hand was. Pin 6. Which one is pin 6? 6, 5, 4, 3, 2, and 1. Oh, they're labeled on the board. Okay, so I'm gonna have to like get in there. All right, let's get in there. Let's plug this in. I want to at least look at this serial signal before we adjourn. And we'll probably keep going for a little while today. I'll probably go into a little bit of overtime. I've owed it to you guys to do a little bit more streaming because I've been kind of keeping it kind of tight and missing a couple streams here and there, you know? I know you guys think I've abandoned you. Which one is pin 6? Well, there's a 0 right there. I'm gonna go with the dot as being pin 1. There's like a dot in between the two serial things here. Come on over here, chat. Shove your face into this. That's right. There we go. There's the view. Not the show the view. Okay, or not. It could just move. Yeah, that's acceptable, I guess. Okay. Doot. There we go. So the header that we want is this one right here. What we want to do is we want to connect TX and RX. So pins 4 and 5, and then pin 1 is ground. So I am going to use, I don't know, forceps. Why not? Let's use a pair of forceps to help me reach in there. The camera angle is not going to help me. 1, 2, 3, 4, 5. 4 and 5. And I plug in the header. Like that. And like this. Did I miss? I missed. My finger's in the way. Now you guys can see what's going on. A lot of times I have to like stop what I'm doing and figure out the best way to capture something so that you guys know what's going on, even though you guys routinely have absolutely no idea what's going on. All right, one there, and then this one here. Oh, that's the wrong header. I want to do it to this header. This is cool because I don't have to actually solder it. I thought I'd have to solder wires onto the module in order to monitor what it's doing, but I don't. I can just listen in on it from here. And we'll fool the Granite Devices controller into thinking that multiple ones of these serial monitors, or multiple Bluetooth devices are connected. That's my secret. I never know what's going on. You'll never catch me. I have the wrong qualifications for this. What is this? Electricity? What is that? I can actually twist this around now. I can have this facing the other direction because I need the power cable to get in. So now that we have this nice serial connection, a really nice serial connection, I can just do that. Put this like that. Well, these are still very much in the way, but we can take these 3 lines, and now I can attach jumper wires to them. Yumpers. And get these yumpers on there. We can have our TX and RX. I can see what kind of shit's running around on this here line. All right, where are my other jumpers? Actually, we'll just use the ones coming off of the probe. Because the probes have plenty of reach. It's a small oscilloscope, so I often bring the oscilloscope to what I'm trying to measure instead of bringing what I'm trying to measure to the oscilloscope, which, you know, don't have to do that. What was that? Weird. I need a black wire. This one. Got him. I try to match the color of the wire to the probe channel. Don't let the cables jump. You're not my dad. I don't think. What are you doing on Twitch, Dad? Get off of Twitch. It's not healthy. All right, there's that, and we can bring that over to these and poke them in. That's it. Isn't that a streamer? All right, so poke them in. Doesn't matter which one's TX and RX, I don't think. Hello? There it goes. I like wasn't plugging in. All right, that one. This one. And then our ground right there. And now we just boot up this whole piece and see what happens. See what explodes. Oh yeah, I need to plug it into the wall. Are you winning, son? Yes, actually. We've been doing pretty good today. We do good. We did good around here. We did a lot of good stuff today. The pedals are like super duper stable. They're incredibly stable. Hello, cereal. Ah. Well, the wheel thinks that things are crooked. But that return spring's working. Boingy, boingy, boingy. So that's it controlling the motor to do that. Now, we've got a serial signal running around. Look at that. Beautiful. It looks like our RX isn't doing anything. We only have TX. Which I guess makes sense, because I don't know, it doesn't appear that anything is being requested, and that could either be a problem with the voltage levels. No, these are 5 volts a div. These are hooked up. They've all got ground. I just don't see two-way communication here. I only see one direction. So I could have plugged it into the wrong pins. That might have happened. Nah, it's definitely on 4 and 5. But we do have a serial signal in here. I gotta be really careful, because if I do something wrong with this and I blow it up, I'll be very sad. All right, so here's what we're gonna do. We're gonna take pollution down to 0. Gonna help them plunder. Bad guys who like to loot and plunder. Point has to do. Looting and polluting is not the way. Here's what Captain Planet has to say. The power is yours. Okay, so we've got an edge trigger on channel 1. It looks like there are... this signal is just fucking with us. Hey, 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 what are you doing over there? Hey, come back. Hey, hey, stop it. Stop. What are you doing? Okay, so let's zoom in on this and see what we've got in our serial coming in. A lot of data. Lot of data. Lot of data. Lot of data. So we got to stabilize on this thing, and I think the best thing for us to do is to stabilize on the length of this signal right here. Because we don't really know, I mean, we do have a little packet information coming in here, but, you know, we don't have anything to, like, stabilize our input. So what we can do is we can go into the type, and we can do a pulse. And so we want a positive pulse, channel 1, and then we need like multiple milliseconds, because I don't think that's going to do it. Yeah, we need to actually go in and get a keypad on that. How do we do that? There we go. So let's do like 3 milliseconds maybe. So 3, and then I have to go in and key in MS. Now that's a hell of a lot more stable. Not quite. Not quite. But when we zoom in enough, it does get kind of stable. How long is the in-betweens? All right, so let's do a single trigger. Bop. All right, let's move out a little bit. Single trigger. Yeah, see, look at this. So we've got like varying packets of data running around. We're probably going to need a serial signal interpretation thing going on here. But what I want to do is I want to key into the minimum amount of length that's between these things. Hold on, I don't need this here. What are you doing? What are you doing? What are you doing? Stop it. Get out of this. Okay. Cursor. Voice activated oscilloscope. Boop, 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 boop. 30 milliseconds. So let's punch that into our trigger. Hello? Hello? Oh yeah, that. No? This. There we go. 30. So 3. You guys seeing this pretty good? I do have a bus pirate sitting around somewhere. I don't know what happened to it. I thought I could use Wireshark, but I don't think you can. I don't think Wireshark does this. It would be nice though, because I mean, we'd like to see, we'd like to group similar packets, you know? Now I could just take this capture and try to characterize it, but there's a lot of data in here. It looks like these are just bytes, so I think we're doing okay in that regard. I don't know what, I don't think there's any like addressing going on here. Like all the way here at the front of the packet. This is gonna take a while. I don't know if that is stable or not. So let's run this again. Yeah, the trigger settings are gonna be tough to those are gonna be tough. Not like greater than? Yeah, there we go. Nope, never mind. I think sometimes it's a periodic packet. It's not necessarily always coming in. But you can see the stability of these addresses right here. That's always communicating the same thing. Almost. I think I saw it change just then. Now it's pretty stable up there. Oh, up. We lost it. It's back. Counter? That kind of looks like a counter. Hard to work with a packet when it's coming in like this. We're definitely going to need to read values and interpret them. Oh yeah, but there's no wireless wheel module hooked up either. What is your most favorite tool in the workshop? Next question. Why is that wet? wait a minute, why is that wet? Alright, fuck. Why did that get wet? I guess it's not wet. It's just cold. Is that a big wave emote? Oh no, it's a Sark. All right, yeah. So we're actually not communicating with this guy yet. So we need to get power into this. So I need to get a positive and a negative pin, and we just plug it into, what was it, 3 volts? Because it's a battery operated device. So we need about 3 volts. I can just hit it with that. Be happy, and then it'll finally be happy. And we'll see how this changes. So we don't hit it with the 15 volts that we have the power supply set to. That would be a disaster. It's interesting that there is power. There are serial signals running around on this thing, basically just asking. Hold on, looking for 3 volts. So 3 volts over here, and then I can do negative and positive. And then I'm going to turn it on. 3, 2, 1, power. And I just saw a little flashing going on, and it's getting an RX. Look at you, you little bastard. Now we've got a fairly regular signal on here that is asking for data. Oh, come on back. I can't zoom in on it. Let's do just like a single. There we go. And now I can actually get up close to it. Look at you. You bi-directional communicating little bastard. I've got you. I've got you. I know you now. That's right. You can't get away for long. That's not too hard to figure out what's going on, huh? So, what is the length of that? Cursor. The problem is if I key it into that, it's still going to be all over the place. So I really need to key it into something. If I take the cursor here, what if we key it off of this pulse? Where's that transition? That's going to be 384 microseconds. No, wait, no. That's, where's my delta? 590. 590 microseconds. If this is held high for longer, but then it's still going to trigger off of nothing. See, that's the problem. I would assume that yellow is communicating with the module and blue is the module communicating back. The module's communicating back with a very small packet, and I don't know. It's going to be hard to capture. Did it go to sleep? No, it's just. I think we could trigger off of. Oh, I just hit normal mode and it worked. Hold on. Menu, type. Run, window, delay, stop, hold, timeout, duration, pattern. I don't know about pattern. Pattern is pretty cool, but I think maybe we can do RS-232. Run the scope. No, it hates that. It hates that. Other polarity. The more complicated the trigger is, the more delay we're going to get. In normal trigger mode, it was actually doing a pretty good job of sticking to the signal. So look at that. The module gets a certain amount of time to reply. Now, there's going to be other stuff to this packet. This isn't going to be everything. But let's take a look at what happens when I push the button. Okay, it is fucking impossible to see what's going on here. It's really difficult. Stop. Okay. So this is the packet. Oop, no. What am I doing? That's intensity. Moving over like that. So this is our reply. I can actually make that trace into a reference. So sources channel 2. 0 offset, reference 1, save. And then I can turn off, well, I can move channel 2 down. Damn it, that's the wrong button. I keep going for the wrong button. I can move channel 2 down. So now channel 1 and channel 2 are just sharing space. And we know what our previous packet looks like. I know, I can't believe normal mode is the best mode to use on this thing. Sorry, if everything was out of focus, I'm sorry, I was concentrating. This is actually really good stuff. So. Now, we'll make an Arduino look at this stuff. We'll figure that out in a minute. But right now, what I can do on the scope is just get kind of a sense of what's going on here. So let's run this for another single trigger, but this time I'm going to hold down a button. There he is. All right. So, what do we got? I don't see a change in data. Data did not change at all. Unless my buttons are broken or some. Run it again. Single trigger. This is holding down one of the trigger buttons. No change in data. Dun, 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 dun. Hold down the other trigger button. Doot, 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 doot. Nothing. No change. What the heck? That's weird. Why? How could there be no depreciable difference in data sent back from the module? Unless maybe it's like not. Well, let's check to see that everything's like plugged in and working within the whatever it is, within the actual thingy-majig, the Granite Devices controller. That's what I'm looking for. So let's do Granity. Oh yeah, that we run it from the folder. Project, stream, Mercwheel, Mercwheel, and then we're looking up software. SimuCube, I think is the, yeah, this is the one. Configuration tool. Open that up. There we are. Now, are my buttons working? Oh, they are. Wait, why did that toggle? What the hell? The buttons are like toggling on and off. What the? What? Wait a minute, what's happening there? Why are they? They're like toggling. They're certainly not supposed to be. Maybe it's far enough away that it's like not getting good reception. No. Wow, that's weird. That is weird. I have them hooked up wrong or something. Let's take a look at the wireless wheel. unnamed, got a MAC address, signal strength is 100, battery's at 2.99. Maybe I want to take that up to like 4. There's 4.01 finally. So that got that information almost immediately. Oh, there we go. Now the buttons respond much better. Yeah, okay. So it was in like a low battery state. Which means if I do a single capture now, where's our change in voltage? It's the same fucking packet. What's going on here? What the heck? How is that still the same packet? I'll hold down a button, do a single trigger until I get the signal. There we go. Hold down a different button, same response. This is like an I'm still alive or something. Here, let's get the reference off. Let's do another single. So that, maybe this data over here is what's changing. It is a very periodic signal, huh? Problem is, it's coming in slow enough that I can't compare it to itself on the same screen unless I do capturing, in which case we saw a lot of numbers that were like counting around and doing weird stuff. Like, when is it checking to see the battery state? We don't know. Push down one of the triggers and we just see data rolling around. So yeah, I think I'm gonna have to make something that'll analyze this. Tried to translate. The translator got a headache, so it stopped. No, you guys, we don't need to go to that level. And also, this thing will break it down into packets too. The scope actually is capable of doing that. So if I actually took this thing and I went, did a single capture, and then I can go to, oh God, I forget. Measure, channel 1, counter, measure all, no. Oh, it's getting a Hertz number on it. It's not the measure menu. Hold on. There's like a whole thing for working with serial on this thing. I don't think it's the math menu. Oh yeah, it is. Decode. Okay. Decode 1. Decoder. Parallel RS-232, I2C or SPI. I think we're parallel. Turn it on. And it's giving us data here, although it doesn't appear to know what it's doing. It doesn't appear to really know what it's doing. That's not it. What if we turn it on to channel 2? Oh, I see. It's looking for a clock. Yeah. Yeah, I think it needs a clock. Doesn't have one. What, RS-232? That makes more sense. I don't know if that's correct or not. 115200, I'm not really sure what the baud is. It appears to be getting data from this, though. Of course, I can't read it when we go in that close. Channel 1, 5200, yeah. No! Wait, no! There. Problem is, I've never gotten this to really work all that well. Got the right polarity. MSB to LSB or LSB to MSB? Data 8, stop 1, parity none. I don't know, guys. I don't know. This is neat. Naturally, I have meetings. Yeah, we're just poking around at the serial. I'm going to have to make something that receives it. Wait, why are those 3 at 100%? Yeah, well, the pedal works, sort of. Why is this so slow? Wait a minute. What's going on here? Look at how slow this is. Here, I push down a pedal a little bit. It's like clunk, 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 clunk. That's really weird. Yeah, the software is super slow. Oh, maybe it's because I still have the serial monitor up? No, I don't. I don't know why it's so slow. That's like kind of creepy slow. It really shouldn't be that slow. Unless it's doing that much coordination. Because this is like fast. It was like real time. Here, I'm gonna recenter the wheel right there. There. I guess that sped up a little bit. But like the pedals are super slow. Now, not anymore. Wait, why did it suddenly get all this speed? It suddenly was responding properly. Yeah, and the buttons work faster too. And the buttons are up to speed now. Okay, that was weird. What's going on over here then? I'm gonna turn off the serial monitor because it's really not useful. Yeah, I can't. They're so periodic that zooming in isn't really all that effective. It seems like there's a call and response, and sometimes it doesn't respond. There's a call and response, and so let's see. Let's see if I push a button. What the? Like missing out. There's like a huge packet that comes back off of this thing. Wait, I pushed a button and the whole packet went away. Punching this thing is like... The heck? Oh, it's back to responding really slowly. Wait, what the fuck? Wait, what? It's back to like barely responding. Is it the signal strength if I move it closer? It's really inconsistent. I don't know what's going on. It really shouldn't be this inconsistent. It should be like pretty much locked down. And it was working perfectly fast before. Maybe it's because I clicked out of the software. That might have been it. It might be. Yeah, let's try that. Here, you guys come back over here. And we'll trigger off of channel 2. And we won't do RS-232. Although RS-232 was working. I mean, we've got... Well, we might be at the wrong bit, the wrong baud rate. 5200. And that is actually working now. Okay. Reset horizontal. Zoom in. Show me what you're doing. Channel 2. I'm gonna move you up a little bit. I'm gonna bird up. Problem is, it's so slow that I'm having trouble like focusing in on it. So single trigger mode is really what we want. But if I run that and run it again and run it again, yep, okay, cool. So that's stable. So we can zoom in and hopefully get to the same spot every time. Yep, boop, boop, boop. There's that. I don't know if that's like a request or what, because if I push a button and I request this again, push a different button, push both at the same time. It's the same packet. It's always the same packet. I'm wondering if maybe this is the module and this is the Granted Devices controller saying, "Hey, you can give me buttons now." And then this sends back all the... But wait, we were seeing all of this information before we hooked up the wireless module. We were seeing that other packet over there jumping in. Now we've got this. So that signal compared to... Now, here's the thing. If I take that as a reference signal, that channel 2, channel 1, and I save it, right? So now I got that reference. But if I get another signal, well, the timing is a little weird. That one is pretty much on top of itself. But I saw numbers that were like counting in... Oh yeah, the signal reference doesn't scale with everything. I saw stuff that was like counting. That's a checksum. And there's probably like a little bit of a difference there. What if I push a button now and I get, aha, aha, chat, aha. What if I press the other one? No difference. Okay. Press this one again. Whoa, that's a totally different. That's just totally, the timings get a little weird. No buttons pressed. Looks the same. Button pressed. I think right there. Press the different button. A different checksum. Both buttons at the same time. No buttons. Let me press a unique button on it. I need a jumper for that. So I'll grab this jumper right here. I'll try that. And you guys should be able to see what I'm doing while I'm doing it here. Move this like that, so you guys can at least see that I'm pushing stuff. I'm not lying to you. So ground to any old button. We'll push this one. I'm seeing a little difference in here, but I'm not really, I don't think this part of the packet is actually taking our button presses with it. I'm seeing the button being hit in the software. Like this packet is always the same. This one has some difference with a different checksum. I'm going to lower the voltage to 3 volts. All right, so that's 3 volts. Yeah, 3 volts is going through this thing, and let's get another one. No significant difference in that packet. It's the same fucking packet. What the heck? Unless this is carrying all of our data, but that's where the checksum should be. It's like got a counter in it. What the fuck? What are you doing to me? It's just saying the same shit over and over again. All right, go back up to 4 volts so we at least get good communication. Boop. Oh, that's still 3. Hold on. 4 volts. Oop. 4 volts. Same packet. Same packet. Okay. How about the other side of this? We'll have to change our reference. We got a whole nother packet there, so let's take that as a reference. Ref 1, channel 1, save. I could expand that a little bit if you guys need to, if you guys are getting scared and you need to see it a little closer. Just move it like that, and then I'll do save that as the reference. So there's our reference. Oh, hold on. We need to get it to be a little bit more stable so that we can get it to line up with itself. That, or I could just move the reference. Let's move it like that. We'll just do a cross compare. Okay, push the button. Single. Same signal. Push the other button. Single. Push that single button, chat. There's no difference in the freaking packet. What's happening here? I'm gonna push one of these buttons. Same packet. I wonder if it's got like a button down, button up kind of thing going on. We definitely saw a difference in the signal compared to when the thing was turned off. But is there another type of packet that's running around on this thing? Because we see that when we zoom way out. If I just run it, we get that there, and every now and then this doesn't get a full packet and it just does a full like frame. I do not know what's going on here, chat. I think there might be a more periodic thing going on. No, they're not toggle anymore. They're responding quickly now that I've given it enough volts. Okay, so there's a slightly different thing going on when I push a button. It might be that there is a event-driven packet that we're not seeing. See, bop, bop, bop. And then when I push that, things go a little crazy. I think that's what's going on. I think we have an event-driven packet. So there's some kind of like a check-in going in with that. I wonder if that contains the MAC address. That's a lot of data, though. Let's zoom way out. Zoom way, way, way out. Yeah, there we go. All our packets are going to look like little blips, but when I push a button, that appears and then goes away. That little guy right there. I want to see that. How do I see that? I can get lucky, but it's like a million miles away. I think we're just going to need like a packet handler. Because, yeah, it appears to be event-driven, which is good for us. It's good for our microcontroller, because we can definitely respond to the little call request that it has. We can definitely respond with the right data, depending on what the device is supposed to be. But if we've got a packet that only appears when a button is pressed, that's kind of perfect. That's actually good. Now, if I did do like a, here, push the button and do a single trigger, I tried to zoom in on this, I don't think I'm actually going to be able to see any data in the packet. Maybe we will. Oh, actually we will. Let's take that as a reference. Let's see if we can do this again. What kind of data is in there? There's a lot. It's actually a pretty big packet. So one of these represents, I bet, voltage, and then the other one is the 28 buttons that are connected to this thing. 28 over 8? Nah, that might be a little weird. Okay, so take that as a reference. Ref. Save. There's our reference. So we'll overlay another capture on top of it. I don't know if we'll be able to get that because we're triggering off of channel 2. Okay, yeah, let's zoom out. Why are there no packets? What's going on? What did I do? Recenter. Huh? Why are we not getting anything? Did I knock the serial thing off, or? Oh, there's a little data. Oh, it's like all the way over there. Okay, all right. So if I hit the button... Uh-oh. No, no, no. Get out of discovery mode. Oh, there's all kinds of crap going on now. Oh, look, we're still actually dialed in on it. Not anymore. Okay, I need to go way out, and then it... Yeah, there's our packet, but I'm looking for the button push. So that pairing thing, I don't know how to do. There it is. Okay, cool. We found one. That's the button, I think, pressed, or maybe released. I'm not sure. Just lay it on top of itself. There's a lot of differences here. In fact, the entire packet is a different length. Unless I need to zoom in one more. No. Nope. Nope. Can I use the signal inspector on this? It doesn't change the reference. The reference always looks the same. That's annoying. Here, let me move the reference up. By way of comparison, that's the same. There's a change here. That's the same. Same. Possibly a slight change, although it does kind of look samey, but there isn't a bank of zeros right there. Same data. Same data. Slightly different. That's actually still there. Different checksum, or whatever this part is. All right. Well, that's the only packet that we see that changes. I know the connectors. Yeah, it's not a cold oscilloscope, and I put a knock to a fan on it. I remember everything is scaled, so when I actually show like my body temperature, oh, it actually is pretty warm, huh? All right, so progress. This is looking a lot more promising. It appears that we will be able to make our own packet and inject it into the system in order to give it button presses. We just have to figure out what the overall structure of the packet is. What I suspect is being done, we don't know exactly everything about it yet, right? We have to kind of fish into it and start playing with it a little bit. I don't know what the handshake is when things initially power up. When the Bluetooth module goes into discovery mode, there's a completely different set of instructions that are running around on the TX and the RX lines. And we have to figure that out because the Granite device's software is going to want to know what the address is of that wireless wheel module. So we have all this data here that we need to basically spoof in order to tell the Granite device's controller that a button is pressed. Or maybe we don't. If we don't have a wireless wheel module and we TX and RX a button press in the same manner, I wonder if it'll just listen. I don't know, though. Those BNC jacks look visibly warm. I wonder if there's just a big fat linear PSU in there. I can assure you that that is not what they put in research equipment. It's an oscilloscope. This is a fairly more complex device than you would typically see in electronics. I'm sure there is an extensive and heavily engineered power supply inside of this thing. But I also downgraded the fan so that it was quiet, because this is a production device and it needs to be quiet. It needs to shut the hell up so that I can stream. But anyway, all right, so we've started in on the serial stuff and it's getting a little promising here. I'm not going to make any promises, but what I feel like we should be able to do is spoof a packet and inject it and see if we can press a button. I don't know if we can exactly copy these. I think what we should probably do is go to the Arduino serial stuff and just have it poop out ones and zeros into the serial monitor and see what we get. I don't know what the deal is with the TXs and the RXs, though. I don't know what this is all about. Why is there the same signal? Sorry, this isn't what it is. That's the different one. There's like it's like a keep alive request or something that's coming from, I don't know. Is it? I guess it's coming from the Bluetooth module. I guess. But no, the Bluetooth module is transmitting back on that line. But when we didn't, what happens if we don't have a module plugged in? Let me just put that one to bed real quick before I wrap up. Okay, there. Sorry, I had to manhandle my bazangles. I had to manhandle the spring arm back into location. Yeah, power down. Powder down. And away it goes. And then unplug them a jig. As soon as I powered down, the Bluetooth module started flashing. So something, definitely a keep alive. See that? Big pink LED is just flashing away its life until it probably turns off. We'll just turn it off manually. Oop. Turn it back on. Turn off the reference. Hit run. Back up on our signal. Lots of requests coming in from the controller. Lots and lots of them. So that's from the controller. And then this is from the Bluetooth module. We saw a lot of stuff there. So it's requesting a lot of different things. Okay, so armed with that information, we can come back to this on probably Tuesday, unless I'm fairly, well situated and motivated and I've paid my taxes in time. But I got a lot of work to do with that stuff. Why is there a permanently pressed button on this? What's going on there? Who are you? That's the Linbus thing. Oh, this is like responding like ass for some reason. I don't know why it does this on this computer. Yeah, one of these buttons is permanently pressed. I wonder if that's coming in badly on the packet. Ah, it feels good to have the wheel working again. Oh, there it goes. I don't think I have the horn represented. I think that might be down to the microcontroller. I need to like deprogram all of those buttons because we're going to turn them into digital modules, wireless wheel modules. So we can see, oh, it's actually not doing anything anymore. There's no signals here. Yeah, there's nothing. So it requested for a wireless module for a little while, and then it just gave up. New behaviors going on here. We've got all the tools that I think we need in order to produce a well-functioning machine here. I think we've got a lot of good stuff going on. I hate how these are ranged up to 65,535, but I have to lower them all the way down. See these numbers over here, 65,535? We have that kind of granularity to this signal, but we can't utilize it because we have those digital potentiometers that take 0 to 255. Kind of sucks. I wonder if there's a packet type that allows us to communicate analog values. That would be kind of cool. Then we could get full data back. We can get the full 10 bits. The digital analog to digital converter in the AT-Tiny85 is fairly limited, isn't it? I thought isn't it like 10 bits? But anyway, okay. So we've got a serial packet, right? And whether or not, I mean, if I really want to be lazy about this, I could plug in the wireless module, and I could have it doing the serial communications, and then we can just piggyback off of that. But what I'd rather do is have something that communicates with the microcontroller on its own. Now, the question is whether or not we need to tell it that we have a wireless module, or if we can just tell it that buttons are pressed by sending that periodic packet. That packet appears when we push a button. So I'm wondering if we can just hit it with that packet. So what we'll need to do is we'll need to configure a man in the middle. We need to put an Arduino on this serial communications line and listen in and then give us numbers. So we'll figure that out on Tuesday. I might forge ahead and make some progress on this on my own, but at the moment, this is pretty cool, right? Hope I can catch serial decoding and spoofing streams. Yeah, me too. All right, good progress today, guys. We got a lot of stuff done. This is the last piece to getting my whole wheel system configured and everything. We got super stable pedals. The shifter is there, and we're getting the packet all the way on the other end. We just need, and all the buttons for the steering wheel obviously are there too. We just need to tie it all together, tie a big bow around the whole thing, and tighten it until I don't know, turn red. That was fun. We will get back to this kind of stuff. I will be back on Tuesday, and if I see you guys before then, there'll be a puppy stream. Maybe puppy and serial decoding, but probably not. I need a haircut. Anyway, yeah, thank you guys for joining me. I really appreciate it. Those of you guys who subbed, you know, they've been trickling in lately. We had 3 raids: Chemist Security, CosmoQuest, and Code Rush. What is it with C's? Everyone who raids my channel is a C. I appreciate you guys rating me continually. It's actually really heartwarming to get all these raids. And then we had a bunch of people sub with some big numbers next to their names. I really appreciate you guys coming out here and supporting me. We'll get back to this. Yeah, we're making good progress. We're getting there. I'm excited about this, and I will see you guys Tuesday. Here's your end card. Doot 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 bop. Whoa. Was that my computer lagging? Maybe it's the computer that's the problem. I do have a lot of stuff open right now. All right, I will catch you guys later. Have a good one.